A pleasant morning to all. A pleasant morning to all. Welcome to the GPDP training on regulating LNG projects. I am Angelu Pagova of the Gas Policy Development Project. This training is co-organized with the Department of Energy and the Commercial Law Development Program, or CLDP, of the U.S. Department of Commerce. We have a fully loaded morning ahead of us, so let's get to the program without further ado. To mark the start of our program, may we request Dr. Rizalinda De Leon, Project Director of GPDP, to deliver her welcome remarks. Dr. De Leon.
Thank you very much, Angelu. DOE-OIMB Assistant Director Rodela Romero, with our partners from the DOE and other government agencies, USDS Program Manager Robert Lehman, and our colleagues from the US government, and from the GPDP2, ladies and gentlemen, good morning. Good morning, Philippines, and good evening to our friends in the US. We at GPDP are glad to welcome all of you once again to our training. Today's training, the second one in a series of capacity building activities, will be focusing on regulating LNG projects. Through our esteemed experts, we hope to provide you with more knowledge and understanding on the regulations aimed at ensuring health, safety, security, and environmental protection. Today's training will particularly delve on international LNG technology standards, including the management of LNG projects adjacent to the marine space, as well as trucking safety regulations, among others. As natural gas is poised to be the transition fuel that will lead us from our present coal-fired generation capacity to a cleaner energy future, we need to put in place a proper regulatory framework that will help ensure the transition from a nascent natural gas industry into a stable and thriving one. Through a well thought out and foolproof regulatory framework, investors' concerns on project risks or delays can be eased and avoided, thereby expediting current LNG import infrastructure projects into going online. We hope that with today's training, we will all be provided with the essential tools and know-how to map out such framework. Today's training wouldn't be possible without the support of the U.S. Department of Commerce Commercial Law Development Program, who helped us design and organize this training. Big thanks once again to Sue, Mohammed, and Vanya for all the help. I would also like to thank our resource speakers, Mr. Andrew Kohout. I hope I said that properly. Commander Nicolette Vaughn, Mr. Thatch Nguyen, Lieutenant Commander William Hickey, Mr. Joseph Brown, and Ms. Lindsay Constantino for the time and effort you've put in and joining us at this hour, at this unholy hour for you in the US, and coming up with the presentations we will hear later on. Thank you very much for sharing your knowledge and expertise with us. On behalf of the GPDP, I thank each one of you once again for joining us this morning or this evening. We look forward to your active participation. May we all have a productive time. Thank you and mabuhay.
Thank you very much, Dr. De Leon, for that wonderful message. Now to give his remarks is Mr. Robert Lehman. Mr. Lehman is a program manager in the U.S. Department of State's Bureau of Energy Resources, where he specializes in gas sector and mining sector development. He has also served as the energy officer for U.S. Embassy Hanoi. Prior to joining the Department of State, Mr. Lehman worked as a consultant for Booz Allen Hamilton and served in the U.S. Air Force as a cryptologic linguist. He holds a Master of International Affairs from Columbia University and a BA in Economics from the University of California, San Diego. Mr. Lehman is a half Filipino, the son of a Filipino immigrant, which is part of the reason he chose to lead this project for his bureau and is excited to be supporting the US Philippine diplomatic relationship. Ladies and gentlemen, Mr. Robert Lehman.
Thank you, Angela, for that introduction. I appreciate it. Good morning to our DOE and Government of Philippines colleagues. I thank you very much for joining us here today. And thank you, good evening to my fellow colleagues in DC. I really thank you for leading this training and putting it together and all your hard work. I wanna thank everyone for joining us in the second in a series of workshops led by, as Dr. De Leon mentioned, US Department of Commerce's Commercial Law Development Program, or CLDP, and funded by my bureau, the US Department of State's Bureau of Energy Resources, or ENR. Today's workshop is intended to expand on the lessons from the first, with a focus on regulation of LNG projects, both onshore and offshore. In order to deliver the best possible instruction on these topics, CLDP has assembled a team of the US government's foremost experts from various agencies, including the Department of Transportation, the Federal Energy Regulatory Commission, and the US Coast Guard. To echo the remarks by the US Embassy in Manila in the first workshop, I just want to quickly go over that ENR and CLDP work together to build capacity with partner countries across the world and promote fair and transparent energy markets. And I will say, I think we work together all over the world, but I think our cooperation in the Philippines is among the most important. This cooperation with the Philippine DOE and the GPDP2 team is in support of the ENR-led whole of government initiative, Asia EDGE, that you might be familiar with. EDGE is an acronym for Enhancing Development and Growth Through Energy. And it's also in support of the Memorandum of Agreement signed between Secretary Alfonso Cusi and the GPDP2 team on April 29th. I just want to say we're pleased to continue and deepen this cooperation in support of the US-Philippine economic and energy relationship. Thank you once again to everyone. Thank you CLDP, thank you DOE, and thank you for your time. Thanks.
Thank you very much, Mr. Lehman. We are delighted to have you in today's training. Before we move on to our first topic, we wish to acknowledge the following agencies with us today: Department of Energy, DILG Bureau of Fire Protection, DOLE Bureau of Working Conditions, DOLE Quezon Provincial Office, Batangas City Engineers Office, Marina, Philippine Coast Guard, and Senate Committee on Energy. Thank you very much for being with us today. Finally, just some quick reminders to all the participants. If you have any questions to our resource speakers, you may post a question in our chat box. We will be reading your questions during our Q&A session, which will take place after 2 presentations. Kindly make sure to note to which speaker you are addressing your question. Alternatively, you may also take note of your question and press the raise hand icon during the Q&A session so we can call on you and you can ask your question directly. And of course, we encourage everyone to actively listen to our discussion because we will have a quick game later on where you can win amazing prizes. It's not grand, but it surely is useful. So it's a surprise. So stay awake and listen to our speakers. Lastly, we will be preparing certificates of attendance for the participants of today's training. Kindly make sure that you answer the attendance form. So we will have your complete details. A link to the attendance form is posted in the chat box. Now, let's proceed to our first presentation, which is an introduction to the regulatory framework for LNG projects. This will be presented by representatives of 3 U.S. government agencies. First, we have Mr. Andrew Kohout. He is the director of the LNG Facility Reviews and Inspections Division, Office of Energy Projects at the Federal Energy Regulatory Commission, or FERC. He oversees a team of multidisciplined engineers responsible for the safety, reliability, and engineering reviews of LNG facilities. Under FERC jurisdiction throughout the life cycle of the project, including front-end engineering design, final design, construction, commissioning, startup, and operation of facilities. Mr. Kohout is a licensed professional engineer and earned his mechanical engineering degree and 2 fire protection engineering degrees from the University of Maryland. With him is Commander Nicolette Vaughn, Chief of the Cargo Safety and Security Division, Office of Port Facility Compliance of the United States Coast Guard. Commander Vaughn began her career as a facility and container inspector and then moved on to vessel inspections and marine casualty investigations. Her last field position was the Prevention Department Head at Sector New York, which is the largest field unit in the Coast Guard. Commander Vaughn was also assigned as a Coast Guard Fellow in the United States Senate Commerce, Science, and Transportation Committee, which oversees Coast Guard operations. Commander Vaughn obtained her undergraduate degree in political science from the Inter-American University with a minor in sociology and her graduate degree in emergency management from Arizona State University. Joining them is also Mr. Thatch Nguyen, General Engineer at the Engineering and Research Division, Office of Pipeline Safety of the United States Department of Transportation, Pipeline and Hazardous Materials Safety Administration, or PHMSA. He serves as a subject matter expert in LNG safety for special permits, regulatory interpretations, and rulemaking development, and compliance determinations to federal and state partners. Mr. Nguyen is a member of the National Fire Protection Association Technical Committee on LNG. Prior to joining PHMSA, Mr. Nguyen worked for 12 years at FERC, where he conducted cryogenic design reviews and safety compliance audits of LNG facilities. He obtained a bachelor's degree in mechanical engineering at the University of Texas at Austin. Mr. Nguyen was also a resource speaker in one of our trainings during GPDP1. We are happy to have him again. Ladies and gentlemen, our esteemed experts, Mr. Kohout, Commander Vaughn, and Mr. Nguyen.
Good morning. So my name is Andrew Kahoot. As mentioned, I'm the Director of LNG Facility Reviews and Inspections. I'll be doing the primarily speaking for this presentation, and we'll be deferring to Tak Nguyen and Commander Vaughn during sections on the Coast Guard and DOT for any questions or if they have anything to add. So let's begin. And I have to have a disclaimer in the beginning. So our policy at the Federal Energy Regulatory Commission is that the commission speaks through its orders, and the commission staff is that of opinion and not necessarily representative of the commission, US government, or employees thereof. So just wanted to make that statement prior to when I begin. Next slide. So we'll be going over general types of LNG facilities, key statutes and standards, siting and construction of LNG facilities, and safety and environmental issues for LNG facilities, and then compliance of LNG facilities under FERC jurisdiction in coordination with our federal partners. So to begin, there are generally 4 types of LNG facilities that are under regulation, federal regulation within the United States. The first being export facilities, which liquefy the gas, turn it in natural gas into LNG, where it's boarded onto a LNG marine vessel, which then transports to an LNG import terminal, where it's then delivered typically into a pipeline system. Move forward. And you'll have to click a series. There are also 2 other primary types of LNG facilities within the United States. There's what we call peak shaving facilities, which essentially act as storage during off-peak periods and liquefy the natural gas, turn it into LNG and store it during these low demand periods, and then dispatch that LNG during high demand or peak times as a means of storage. Both import terminals, export terminals, and peak shaving facilities may also have trucking facilities. Those trucking facilities may supply LNG to bunkering stations, satellite stations, or a variety of other end users. There's also what we call satellite facilities in the United States, which are typically smaller scale that may serve things such as distribution, local distribution, and typically will consist of smaller pressure vessel type tanks that often have a smaller vaporizer in conjunction with them that also may send gas to end users or a pipeline network. Next slide, please. So in the United States, there are several federal agencies that can be involved in the regulation and oversight of LNG facilities. So the ones shown are just a few of the regulatory bodies that have a role in LNG siting and oversight. The primary ones that we're going to be focusing on are the ones highlighted in the middle, which is the Department of Transportation, PHMSA, who we have representatives from, Department of Energy, Federal Energy Regulatory Commission, which is the agency I represent, the United States Coast Guard, and to a lesser extent, MARAD, which is also within the Department of Transportation. But there are a host of others, including the Advisory Council of Historic Preservation. You can have the United States Army Corps of Engineers involved under the Rivers and Harbors Act for dredging activities. There are other agencies involved, such as NOAA, which is the National Oceanic and Atmospheric Administration, U.S. Fish and Wildlife Service, that might be involved with threatened and endangered species under the Endangered Species Act. And then there is a host of others that can be involved as well for evaluating the different resource impacts that could be present. Another primary one that we have a lot of interaction with is the U.S. Environmental Protection Agency, and their dealings with the Clean Air Act and the Clean Water Act. But today we'll be focusing on those with the safety and security oversight, which are the agencies again highlighted in the middle. Next slide, please. So some of the key statutes for the various agencies, and starting with Federal Energy Regulatory Commission, is the Federal Power Act of 1920, which first established the Federal Power Commission, and the Natural Gas Act of 1938, which vested the authority to authorize or deny LNG import or export facilities associated facilities into the United States. With the Department of Energy Organization Act of 1977, the Federal Power Commission was replaced with the Federal Energy Regulatory Commission, now FERC. And under delegated authority, the regulatory oversight became bifurcated, meaning that the Department of Energy is now in charge of authorizing the import or export of LNG as a commodity, but the facilities are still rested with the Federal Energy Regulatory Commission. So while we have review of the engineering and design of the facilities, the commodity itself and import and export thereof still remains with the Department of Energy. Other key statutes include the National Environmental Policy Act of 1969, which essentially requires all federal agencies to assess and consider the impacts of their actions on the human environment. This includes environmental impacts and impacts to the health and safety of the public. The Energy Policy Act of 2005 clarifies FERC as the lead agency for NEPA with exclusive authority to approve or deny LNG terminals and mandates implementation of what we call pre-filing, which we'll explain a little later. It also requires FERC to consult with state agencies on local safety considerations and requires FERC to approve emergency response plans and cost sharing plans in coordination with federal, state, and local partners, such as the U.S. Coast Guard and Department of Transportation. Next slide, please. And you can click through this. This is just showing the Natural Gas Act. And if you click through, it'll just highlight the parts that I just spoke to. It's also showing the National Environmental Policy Act on the right, and we'll zoom in on the key parts that I just spoke to. Next slide, please. Department of Transportation, Pipeline and Hazardous Materials Safety Administration, and U.S. Coast Guard also have some key statutory authorities in their legislation, associated legislation, starting with the Natural Gas Pipeline Safety Act of 1968 for DOT PHMSA, and subsequent acts, including the most recently Protecting Our Infrastructure of Pipelines and Enhancing Safety, or PIPES Act of 2020. It establishes DOT PHMSA as the authority for promulgating regulations on siting, design, construction, and operation of LNG facilities. So although FERC has the authority to authorize applications for the siting, design, construction, and operation of LNG facilities, the promulgation of the regulations rests with DOT PHMSA. Obviously, this necessitates a lot of coordination between the two agencies, and there are memorandums of understanding and interagency agreements to establish that coordination. For the Coast Guard, the primary statutes giving them the authorities for LNG facilities rests with the Ports and Waterways Safety Act of 1972 and the Port and Tanker Safety Act of 1978. These acts authorize the Coast Guard to prevent damage to structures on, in, or immediately adjacent to navigable waters. This includes LNG marine terminals. It also authorizes the Coast Guard to supervise and control vessel traffic and establish vessel traffic service and separation schemes for ports, harbors, and other waters. This allows them to have broad authority on the arrival and vessel movements, including LNG marine vessels and carriers. The Marine Transportation and Security Act of 2002 also vests similar authorities to the Coast Guard in regards to security aspects of the facilities and vessels. It requires Coast Guard to develop a national and area maritime transportation security plans. It also establishes maritime safety and security teams in coordination with federal, state, and local law enforcement and emergency response agencies. It also requires vessel and facility security assessments and plans, including security incident response plans, as well as establishing vessel security officers and facility security officers. It also establishes other security features. It also amends the Deepwater Port Act of 1974, which gives the Coast Guard, along with MARAD, licensing systems for ownership, construction, operation, and decommissioning of deepwater port structures located beyond U.S. territorial sea for import and export of natural gas and oil. We'll explain those differences and when they become important as far as what's the jurisdictional landscape of these LNG facilities. Next slide. So in a nutshell, there's a schematic provided here, which is available on the PHMSA website given below, that tries to make sense of all this various jurisdiction over LNG facilities in terms of LNG safety and security. The different boxes and shapes and colors represent different agency oversight for different parts of the LNG life cycle. as you can see, can be quite complex. Today, we'll be focusing on the LNG import facilities, and primarily the ones that are located either onshore or nearshore or offshore. There'll also be presentations from my understanding on the transportation sectors for both the LNG marine vessels and the LNG trucking activities. But this presentation today will focus on the terminals themselves. Next slide. So for the terminals and facilities that will be of interest, and the various kind of safety and security oversights that exist are tabulated and summarized below. So for import and export terminals in the US that are located either onshore or nearshore, FERC would have jurisdiction over the application and authorization of those facilities. The regulations that would apply for onshore facilities would be governed by the DOT PHMSA safety regulations, as well as the US Coast Guard regulations that we'll speak to in later slides. However, there are other situations where they're located nearshore, meaning those within state waters, or those that are located offshore, meaning those beyond state waters, that may have different jurisdictional bounds and agencies involved, as shown here. Next slide. For an example, and the most common example in the United States, we'll show a typical onshore facility that has various interfaces with the LNG marine vessels and some key features in the plant where jurisdictional boundaries change. If you could please click through a few on this slide. So there are pipelines associated with these facilities. If you're an import facility, you'll be sending out typically into a pipeline. Those are governed under Section 3 or Section 7 of the Natural Gas Act and are jurisdictional to FERC generally. There are also the marine terminal itself from that pipeline all the way to the loading arms to the LNG ship. Those are also jurisdictional to FERC under the NGA. However, for NEPA purposes, we also take a look at the LNG marine vessels and the impacts it could have from both a safety standpoint, security, as well as environmental effects. The promulgations, go back please. The federal regulations promulgated by DOT apply to parts of the facility depending on what part of the regulation. So their siting regulations apply from the pipeline to the loading arms, similar to FERC's jurisdiction. However, things other than siting, such as design, construction, operation, stop at a valve between the tank and the loading arms. This is also where jurisdiction changes on safety from DOT to US Coast Guard. So Coast Guard will have regulations from that valve to the loading arms under 33 CFR 127, while the remaining portion of the facilities are governed under 49 CFR 193. The pipeline will also be under safety regulations under DOT for 49 CFR 192. And then for security, Coast Guard will have the entire facility from the loading arms to the pipeline. Beyond the pipeline or part of the pipeline will be the Transportation Security Administration under DHS. Vessel safety and security is also a rest with the Coast Guard. Safety under 46 CFR 154 and vessel security under 33 CFR 104. This is the typical LNG facility or LNG terminal within the United States and the jurisdictions of the various agencies we're speaking to today. Next slide. The following maps just show the various locations of import terminals and export terminals that are existing, proposed, or authorized in the United States. You can cycle through these, please. So what the slides show that there is an abundance of proposed export terminals and beginnings of a large number of existing LNG export terminals. However, just about 10 years ago, the United States was importing LNG. So there are still a number of LNG import terminals that exist. However, most of those have converted to export facilities, with the exception of a few, some of which have been authorized and not yet built, and then two that have not made the switch over and are continuing to import LNG. That within the New England area in Everett, Massachusetts, where they have pipeline constraints from delivering natural gas to their markets. And that in Puerto Rico, which is a territory that also does not have its own natural gas supplies, and therefore continue to import LNG. Next slide, please. So why do we regulate these facilities? We're essentially trying to balance the potential impacts and costs against the need and benefit. There are many benefits for having a robust LNG supply, both in terms of export and import. That could include supply and demand, reliability, socioeconomic benefits, and many others. However, they can also have costs associated with the impacts to air quality, noise quality, safety to the public, as well as security costs. These have to be weighed against each other to determine whether a facility should be authorized or not. And that essentially is the role of the Federal Energy Regulatory Commission. Next slide. We do this by requiring applicants to file 13 resource reports, as shown here. They look at the various impacts to these resources. These resources include a wide range of impacts, such as water use and quality, fish, wildlife, and vegetation, cultural resources, socioeconomics, geological resources, soils, land use, recreation, aesthetics, air and noise quality, reliability and safety. It also will assess alternatives under Resource Report 10, as well as the engineering and design material that forms the basis of the reliability and safety impacts. There are guidelines that can be found on these various environmental and safety resources in resource reports, as shown in the link below. Next slide, please. So the illustration here got a little off skew, but essentially what it is trying to show is that the FERC review starts early in the process. It starts in what we call the pre-FEED or pre-front-end engineering design, or sometimes the front-end load, which is the preliminary engineering design. We do this for a couple of reasons. We start the review early because it allows for the most influence over the design, which is the blue line, at the least cost for changes to an applicant, which is the green line. As you progress in the engineering design through the front-end engineering design or FEED, which is when our application begins, application process, the costs and the influence are inversely proportional. So you tend to cause higher costs if there are changes and have less influence over the design, in part because of the momentum associated with those costs. FERC's citing in CP review tends to end at the end of FEED and the beginning of detailed design. It is often after authorization of FERC applications that final investment decision is reached. That's what then begins the EPC stage of final or detailed design, construction, all the way up to operation. And we have processes for each one of those phases. Next slide, please. So this is just a flow chart of the application process by the applicant and by FERC. What essentially it mirrors what the previous slide, which shows that the applicants will be involved with assessing market needs and considering project feasibility, looking at various sites. That is done before the FERC process begins. Then, once they have settled or assessed those needs and decide they want to move forward, they'll typically request use of FERC's pre-filing process. This is the first stage of a process and is a minimum 180 days or about 6 months prior to when someone will file an application. This early process is done prior to a formal application because it allows for more stakeholder communication without some of the restrictions for ex parte, which basically limits communication during the application process as a formal proceeding. This is because all proceedings at FERC are subject to judicial review. So in order to have a fair process, all communication must be open and transparent. And some of these conversations can't be held then as freely unless all parties are privy to those conversations. Therefore, once you enter the application, or what we call the CP process, all communication is done formally on the record, typically through data requests and other formal letters. Could you please click a few through on this slide? And we'll highlight the various phases. So the pre-filing is outlined there, and the application phase. During this time, we also begin coordination with the various agencies, which is the red that you're seeing. At the time of pre-filing, an applicant must also file a letter of intent and preliminary waterway suitability assessment with the Coast Guard. At the time of application, a follow-on WSA or a way suitability assessment may be followed if needed. We'll also begin coordination with DOT PHMSA on design spill determinations, or what we now call letter of determinations. At the same time, there'll be engagement with the Department of Defense, which we also have an MOU with to ensure that there are no impacts to military facilities or operations. During this time, the Coast Guard is working with the applicant and other stakeholders to develop a letter of recommendation and associated letter of recommendation analysis on the suitability of the waterway. That feeds into our application process and our NEPA process, where we describe the impacts to the various resources described previously, including those that are associated with the safety and security of the marine vessels in the waterway that the marine vessels will traverse. That is evaluated primarily by the US Coast Guard and is summarized in their letter of recommendation. That's provided as part, again, of the application process and feeds into our overall conclusions on the project. Similarly, DOT PHMSA will provide a letter of determination that summarizes their analysis of the siting aspects of the proposed LNG facilities that also feed into our application process, but comes in a little bit later prior to the commission order. Next slide, please. Similarly, for an EIS, the same process applies. So the previous slide, which I should have clarified, was for an environmental assessment. All our reviews are summarized in an environmental assessment or environmental impact statement. The primary difference between the two is an environmental assessment has to conclude with a finding of no significant impact to those previous resources described. And an environmental impact statement may have impacts to those resources and may even include significant impacts. It also requires a draft environmental impact statement to be provided to the public for comment. That comment period is typically 45 days, but can be longer. During that time, we also will hold comment meetings with the public on the draft EIS. Those comments are then considered for the final environmental impact statement prior to the commission order. In both cases, in the EA or EIS, those summary conclusions are provided for the commission to deny or authorize an LNG terminal or facility as expressed in the commission order. If a facility is authorized, the LNG review process enters our next stage, which we call our post-authorization stage. Next slide, please. Given kind of the time constraints we're under, I won't go through this in detail, but essentially our post-authorization consists of a series of essentially hold points for these LNG facilities. So part of our engineering review, we'll make a series of recommendations, typically around 100, that tie to certain notices to proceed that we must issue before a company can begin site preparation, construction, the final design, commissioning, introduction of hazardous fluids, or operation. It isn't until those recommendations, which are often adopted as conditions of our authorizing order, not until those are satisfied do we allow for movement with the next stage. Next slide. So in summary, and you can click through a few here, and some of the I apologize, some of the titles have not come through, that essentially if you look at the safety and security reviews, they're all very similar, and there's three key components as spoken about before. There's the FERC engineering review, the PHMSA regulations, and the US Coast Guard regulations. There are additional external advisory reports and correspondence with other agencies that are also considered. But essentially, they all have the same goal or objective. It's really to identify hazards, evaluate risks associated with those hazards in terms of both consequences and likelihood, and then trying to reduce those risks to tolerable or acceptable levels. Next slide. So as part of the PHMSA siting requirements, as spoken about before, they'll address hazards from accidental releases and hazards from natural events. These are described in 49 CFR subpart B. And to the questioner's chat, it is 49 CFR 193 that defines, quote, exclusion zones for the LNG facilities. This is the area an operator or government agency must legally control all activities that would exclude the public from those areas. Those include hazards of both thermal radiation or heat, basically from fires, as well as flammable vapors from LNG releases. Next slide, please. In addition, PHMSA also considers other hazards that are not associated with LNG, as many of these facilities control other hazardous fluids. So this would include flammable vapor dispersion from natural gas, heat from natural gas piping jet fires, explosions from flammable vapor clouds from both not just the LNG, but also from refrigerants that may be held. This is particularly important for export facilities, and also the potential for what we call boiling liquid expanding vapor explosions, or BLEVEs. Next slide, please. These are just illustrations of some of those hazardous areas using some sophisticated modeling. On the left is dispersion from various hazardous materials, and on the right is overpressures from explosions from some of those materials. Next slide. These are radiant heat zones from fires emanating from the tanks or from what we call impoundments, where any spills would be directed to in the event of a release. Next slide. Similarly, the Coast Guard regulations and letter of recommendation will also have zones. However, these aren't exclusion zones necessarily. These are what we call zones of concern, are used for planning purposes and determining both safety and security measures to be taken. Next slide. These zones of concern are both for accidental and intentional events, and are similarly based on radiant heat hazards from fires and flammable vapor dispersion zones. Again, these are not necessarily exclusion zones for the public, but areas of potential impact for worst case events, and are used more for planning purposes for safety and security measures. This could include and result in safety zones and security zones, but they are not the same. And if there's questions on that, we can have Coast Guard speak more to that. Next slide. And then there's the FERC Safety, Reliability, and Engineering Review, which builds up off of those regulations in both DOT and Coast Guard, where we primarily focus on the, quote, layers of protection. These are described in more detail in our guidance manual, which describes all the information to be filed within to FERC on the applications. In the end, it ends up being a few to several thousand pages of engineering information that FERC staff reviews. And I won't bore you with the details with all the engineering documents that we look at. But we'll go through kind of some of the high level areas of what we do look at. Next slide. So for example, we may look at additional hazard modeling beyond that of siting. The siting regulations call for not necessarily the worst case releases, but may be representative of smaller, more likely releases. So for example, they may be representative of 2-inch or smaller, 2-inch hole or smaller releases. FERC will also look at larger releases that could occur similar to the Coast Guard process for planning and design purposes. So for example, a failure of a tank would result in much larger consequences in hazard zones. Those are not practical to keep the public out of in most circumstances. Therefore, we look at the layers of protection installed to prevent such events from occurring. Next slide. So this just shows some of that advanced modeling that may be done to supplement some of that that's done in the siting process. These are some runs done by FERC staff based upon runs submitted to FERC as part of the siting packages. Next slide. So this just shows the potential consequences in populated areas without giving numbers because it's critical energy infrastructure information. But essentially shows based upon the consequences may inform FERC and FERC staff of the layers of protections that may be needed and the reliability of those protections. It may also dictate whether there's a significant impact to the public or not, as to whether those impacts can be mitigated or not to a tolerable risk level. Next slide. We will also use regulation codes and standards as part of FERC's review. Not only does FERC require a demonstration of compliance with the federal regulations and NFPA, or National Fire Protection Association Standard 59A, which is the primary standard used in the US and also used widely internationally, will also require a list of codes and standards that would be applied to the project beyond that that's in federal regulations. For example, the DOT PHMSA regulations make direct reference to 9 codes and standards, and the US Coast Guard regulations make direct reference to 7 unique codes and standards. Together, they cite 11 unique standards because there's some overlaps where they both cite different versions of NFPA 59A. In turn, NFPA 59A references 56 different codes and standards that are required and recommends another 16. However, as part of the FERC review process, there have been over 2,000 unique codes and standards identified by applicants that they use in the design and construction of the LNG facilities. The majority of applications have referenced 300 to 500 specific codes and standards, for an average of about 365. So this often is much more expansive than those that are in the regulations, and often form the basis and inform FERC of the types of designs that will be carried out through the design. I will note that NFPA 59A 2019 edition includes much more codes and standards, both required and recommended, that are more analogous to those that we see in applications. And the bottom shows us a sample of the various standard development organizations that are often cited, and the percentage of those that make up the standards in the bottom left, which I understand is a little bit difficult to read. Next slide. And you'll have to click through a lot on this one. So I won't bore you with the details, but as part of our review, there isn't a whole lot in standards or regulations on the process design of these facilities. So a big part of our review is reviewing what we call piping and instrumentation diagrams, process flow diagrams, and various other process mechanical engineering aspects of the design. For example, this is supposed to depict a LNG storage tank and the various lines that we would expect to see for startup, shutdown, as well as for safety and redundancy of safety to prevent overpressures, vacuum situations, overfills, and other events, process events that can lead to failure of the tank. You'll have to click through a few more. One more, please. Do the next slide. We'll also look at hazard mitigation engineering aspects and emergency response. Under EPACT, FERC is responsible for reviewing and approving the emergency response plans and cost sharing plans as shared before. We also take a deep dive into the hazard mitigation engineering aspects of these facilities. This is often an area where we see applications may not invest as much for these systems, in part because there's not a return on investment of them. And many times the codes and standards, including NFPA 59A, are fairly vague and subjective in these areas, allowing for a lot of interpretation, which sometimes yields wide varying results and how much protection is afforded. So we'll look at various things, such as the placement of hazard control devices, how much fire water demand they are proposing, how much coverage there is, etc. And this is, again, a large focus of our review. Next slide, please. We'll also look at structural engineering aspects, which is another area where there's some wide interpretation. So we'll look at various things such as wind events from hurricanes or typhoons in your area, the associated storm surge and elevations of the plant, even things such as frost lines or thermal lines to see if there's significant effects from temperatures. Next slide. Or you might have to click through this one. We'll look at past historic events and seismic events as well. Seismic events can also cause two things, both the earthquake and ground shaking, and also it can cause tsunamis. So we'll take a look at both of those aspects, along with a host of other natural hazards not shown here. And those will feed into the loads and load combinations and the structural engineering of the facilities. Next slide. We'll also look at security aspects in coordination with the Coast Guard. Here you're seeing some public available documents on some of the modeling that was underdone under research by India National Laboratories, looking at potential accidental and intentional events and the potential for cascading effects of breaches of the double hull structures of LNG marine vessels. So we'll take a look at some of these aspects as well. We'll also look at facility security aspects such as lighting. So for example, while DOT PHMSA might have some regulations pertaining to the minimum lighting levels of a facility of 2.2 lux, and Coast Guard might have some minimum lighting requirements for transfer areas, which I believe is 54 lux. It doesn't cover a large majority of the other plant. So FERC will rely on other codes and standards, such as API 540, which is a little more comprehensive in the coverage of the facility. And this is for both security and operational benefits from a safety standpoint to ensure that there's minimum lighting provided in areas of operation. Next slide, please. And what you saw on the bottom left there is we'll also look at things as projectiles, including impacts from aircraft, both from an intentional and accidental standpoint on the facilities, as well as other projectile sources. Next slide. All this information that we review is summarized in an environmental impact statement. That environmental impact statement will summarize our reviews, provide our recommendations that then inform the commission order. These can range from a few hundred pages or more, and will also include the summary and impacts to other resources that were previously explained. Next slide, please. This is just an example of some of the conditions that may be written and tied to some of those prior hold points that I was speaking to previously. So you can see there's typically about 100, 120 recommendations that tie to different stages of the construction process. Next slide, please. This is just a timeline of a general construction that we see at LNG facilities. Typically for LNG import terminals, the longest lead time will be your tanks. And that could include, because these terminals are often located on coastlines, there could be a large need for soil stabilization and deep foundations on piles. That can also take a significant period of time. And as you can see here, 1 to 2 years in many cases. Following the foundations, there's structural steel erection, and then final design installation, which includes essentially your pipe racks and your rotating equipment and fired heaters, et cetera. There's usually done in phases, so you might see overlaps in these various stages where commissioning begins before final design is completed. And again, it's kind of a just-in-time engineering where they finish the system, they'll start commissioning it, and then move on to introduction of hazardous fluids and commencement of service. Next slide, please. So once the construction process is complete, then facilities are subject to semi-annual reports to FERC and operational inspections. So the semi-annual reports essentially summarize changes in design and operating conditions and abnormal experiences in both operations and maintenance. It could also include modifications, including future plans, as well as problems associated with various transits, so both trucking and LNG marine vessels. There are also some other leading indicators that we may be interested in that may not result in an actual incident, but could be a sign of a potential problem in their facilities, some of which are shown here. And you can see in this picture, it's a little bit hard to tell, but an example of one of our findings in at a operational inspection. I'm not sure if anyone can see, but there's a difference in the gap in the flange from right to left, indicating that the flange has not been aligned appropriately. Next slide. And that really is the conclusion of kind of our review process that starts with the application, continues through construction, and then into operation. Does anyone have any questions? And thank you, Coast Guard, for filling in the chat box on the safety zones and security zones.
Thank you very much for that comprehensive presentation, Mr. Kohout.
Welcome.
Our
Thank you for having
second
me.
our second presentation is on offshore LNG regulation, managing technology standards, and marine space and operational risks. This will be presented by representatives of the U.S. Coast Guard. Commander Vaughn will again be taking part of the presentation, and she will be joined by Mr. Joseph Brown, Liquefied Gas Carrier Senior Marine Inspector from the Liquefied Gas Carrier National Center of Expertise of the U.S. Coast Guard. Prior to working at the LGC NCOE, he was a journeyman marine inspector at Marine Safety Unit Paducah. While there, his primary duties included domestic vessel inspections and training industry personnel on how to comply with the newly implemented Subchapter M regulations. He also serves as the Coast Guard's secondary liaison to the Society of International Gas Tankers and Terminal Operators, an internationally recognized non-governmental organizations established to promote safety and industry best practices in the safe transportation of liquefied gases. Let's welcome Mr. Brown and once again, Commander Vaughn. Mr. Brown.
Thank you. This will be Commander Vaughn's presentation.
All right.
Apologies, it'll be my presentation. Okay. All right. Thank you all for joining us. I know it's nice and early for you, getting late for us. But today we'll be talking about the U.S. Coast Guard Certificate of Compliance Examination Program. Next slide, please. Our objectives for today will be to describe where the U.S. Coast Guard obtains its vessel inspection authority. We also aim to recall the regulations applicable to foreign flag gas carriers and to describe the notice of arrival regulations, to review the processes for having the U.S. Coast Guard complete a certificate of compliance examination, summarize the navigation safety regulations, and describe the pollution prevention regulations. We'll also dive a little bit into gas carrier functionality and how the U.S. Coast Guard inspects gas carriers, to include floating storage regasification units. Next slide, please. To begin, the U.S. Coast Guard, we get a lot of our teeth from the United States Code. The United States Code is prepared and published by the Office of the Law and Revision Council, the OLRC, of the U.S. House of Representatives. Per 46, back a slide, please. 2 slides. All right, for 46 U.S. Code 3714, foreign tank vessel, which includes gas carriers, must undergo a compliance verification exam conducted by the U.S. Coast Guard at its initial U.S. port of call and then annually thereafter. The U.S. Code is an official codification of the general and permanent laws of the United States. And the U.S. Coast Guard has many legal authorities that are associated with marine transportation, hazardous materials, shipping, bridge administration, oil spill response, pilotage, and also vessel construction. For the certificate of compliance exam, which we're going to cover later, we also collect an annual $1,100 foreign tank inspection fee to help cover some of the costs incurred by the U.S. Coast Guard. Next slide, please. Regarding regulatory compliance, foreign tank vessels, to include gas carriers operating in the United States waters, must comply with the following regulations. They need to comply with the notice of arrival regulations found in 33 CFR Part 160, the regulations pertaining to the bulk liquefied gases in 46 CFR 154, The pollution prevention regulations found in 33 CFR Part 151, nav safety regulations found in 33 CFR Part 164, and then all the international maritime organizations, or IMO, conventions and codes, such as SOLAS, the IGC code, MARPOL, STCW, and the like. As previously mentioned in the questions, you can go to ecfr.gov to read a lot of the regulations that those sections are referring to. We can go to the next slide, please. For notice of arrivals, U.S. and foreign-bound vessels departing from ports or places within the navigable waters of the United States must submit a notice of arrival in accordance with 33 CFR 160.203. The notice of arrival is an important document for the U.S. Coast Guard as it details critical information such as the ship's particulars, the registered names of owners and operators, as well as the 24-hour point of contact. As a Marine inspector in the U.S. Coast Guard, we use that 24-hour point of contact on a daily basis. We call them to find out where the vessel is shifting to, where they're going to be located, when. As many of us know in the maritime industry, no vessel position is certain. So we use a lot of the information found here. The notice of arrival also allows for the U.S. Coast Guard to see the last 5 ports or places the vessel has visited. This information allows the Coast Guard to determine if the vessel poses a greater risk to port security. It's just one of the many little tidbits of information that we use to help evaluate the security risk to our ports. All vessels are required to submit their notice of arrival within the times required by 33 CFR 212 A4. And what that means is if your voyage time is 96 hours or more, then we need at least 96 hours of notice before arriving at that port or place. And then if you're on a shorter voyage of less than 96 hours, we still require notice, but at least 24 hours. For the United States, we have some closer ports within Mexico and some in Central America where the voyage time is pretty short. And so this still gives us plenty of time to review the oncoming vessel or the vessel that's coming to the United States and to adequately screen it. All right. Any updates, as I previously mentioned, that the vessels are constantly shifting, but notice of update or notice of arrival updates must meet the required times as per 33 CFR 162.12 before, as you can see in the slide. And again, it's something similar. If your remaining voyage time is 96 hours or more, as soon as practicable, but at least 24 hours before arriving at the port. If it's less than 96, but not less than 24, we'd still like 24 hours notice. And then if it's less than 24 hours, as soon as practicable again, but at least 12 hours before arriving at the port or place or destination. Next slide, please. So now we're going to talk a little bit about the procedures for having the U.S. Coast Guard examine a vessel for a certificate of compliance. Foreign liquefied gas tank vessels or gas carriers that wish to conduct business in the United States must submit documentation to the Marine Safety Center for review per 46 CFR 154.22 as required by 46 CFR 1802A. Some of the areas that the Marine Safety Center will review will include the hull material of a gas carrier. As we know, liquefied gases are exceptionally cold. As an example, methane or LNG is carried at a minus 162 degrees Celsius. So for crack arresting purposes, the steel around the vessel will differ, especially around the shear strake and the turn of the bilge. For these areas, we'll use a steel that's designed to manage these colder temperatures and arrest any cracks that may occur if there's any kind of cargo spilled. The other areas that the Marine Safety Center will review are going to be cargo tank pressure and temperature control. A lot of these tanks, and we'll cover some of these technologies in a little bit, are going to be protected with all sorts of pressure management systems, but primarily by the pressure relief valves that are going to be on top of the cargo tanks. Gas carriers will typically have 2 on top of each cargo tank, and the Marine Safety Center is going to evaluate whether those are appropriate for the design of the tank. And then as far as temperature control is concerned, the Marine Safety Center will take into account the shape and the design of the gas carrier, of the cargo containment system aboard the gas carrier, and verify that the temperature control systems meet the requirements found within both the CFR and also the IGC code. The Marine Safety Center also looks at ambient design temperatures. The United States, it's a very large country, but on the northwestern side, we have Alaska, where the water temperatures vary greatly from those in Florida and all those warmer areas of the country. And they're going to check to see if the ambient design temperatures are appropriate for the carriage of liquefied gases in Alaskan waters. They just want to make sure that the hull won't crack. So that's another area that the Marine Safety Center reviews. Okay. Once the Marine Safety Center has reviewed and accepted this documentation, the officer in charge of marine inspection, the OCMI, must be given at least 7 days notice before the vessel arrives in the United States to schedule its examination. The subchapter O endorsement, once issued, will reflect a lot of the same information that you find on the vessel certificate of compliance, which is attesting that the vessel meets the design standards found in the gas carrier code, the IGC code. But the subchapter O endorsement will list special requirements that the vessel must maintain to conduct operations while in the United States. During the inspection, during the certificate of compliance examination, U.S. Coast Guard teams will review all pertinent documentation and verify the vessel remains compliant with all applicable regulations prior to any issuance of any documentation. And then upon completing a successful examination, the vessel will receive an endorsed COC, or certificate of compliance, and subchapter O endorsement. These documents will allow for the carriage of liquefied gases in bulk into and from U.S. waters. These documents are valid for 2 years with an annual examination between renewal dates. You see a little infographic on the right there, which just explains the process that I mentioned, starting with subchapter O endorsement application to the 7 days notice of 7-day OCMI notification, and then some of the required items that you'll need on board a gas carrier. Next slide, please. The United States Coast Guard Certificate of Compliance examination, it's a complex examination, and it requires quite a bit of training for U.S. Coast Guard examiners. They're trained to inspect many different types of gas carriers. And the most common gas carriers that we see are fully and semi-pressurized gas carriers, fully refrigerated gas carriers, LNG carriers, to include floating storage regasification units, or FSRUs. In the pictures on the right on the top, you can see a fully pressurized gas carrier. That's an LPG carrier with fully pressurized tanks that store gas up to approximately 18 bar. The one below that is an ethane carrier. While we still categorize that as an LPG carrier, it shares a lot of similarities with LNG carriers, as the tank that's the cargo containment system that's in that middle picture is going to be a membrane style tank or cargo containment system. And then on the bottom, you can see an iconic LNG carrier with type B or Moss tanks, ball tanks in layman's terms. And we inspect all of these different types, and each vessel type will bring different complexities, difficulties, just arrangements and general knowledge that a gas carrier examiner in the U.S. Coast Guard will need to know in order to inspect them to the best of their ability. U.S. Coast Guard COC examination focuses on the vessel's ability to safely conduct cargo operations while meeting the requirements set forth by the Code of Federal Regulations and the applicable gas carrier code. While we do see some older gas carriers, primarily what we find and inspect or examine are going to be those that are subject to the requirements in the 1993 edition of the IGC code, more and more LNG carriers and new build vessels are going to be required to comply with the 2016 edition of the IGC code. And that's something that we learn. We learn all these regulations. We learn the ins and outs, what's different between the codes, and that's something that we train. I'd mentioned that the Coast Guard examiners are trained to inspect many different types of gas carriers. For example, we teach, our office teaches at a class up in the northeast portion of northeastern states in the United States. And then we focus on gas carrier basics from thermodynamics, chemistry, inspections. Let's see. And then the training will move over to their local ports where they'll receive on-the-job training, inspecting whichever gas carriers are most common to their port. Down where I'm located in Houston, Texas, we see a little bit of everything from LPG carriers all the way to LNG carriers and FSRUs. Okay. All right, we can go to the next slide. Here we're just going to talk a little bit more about the United States Coast Guard COC examination. Some of the areas that we examine, and this list isn't all inclusive, it's just a list that I put out there that covers the great majority of the vessel. But we look at the vessel certificates, and when we start with we'd consider the core certificates for a gas carrier. We'll look at the certificate of fitness, which is the attestation that the vessel meets the IGC code. We'll look at the cargo operations manual, which details the processes that the crew will follow in order to conduct cargo operations safely. Shifting their ballast water around as the vessel unloads, to using all of the gas processing units that the vessel has. I know that the Philippines is interested in FSRUs, and there's quite a bit of technology found on those, which I'll jump in a little bit later. But the cargo operations manual details everything that the crew would need in order to conduct those an operation safely. With vessel certificates, we do find some deficiencies. We find that some of the documentation will have expired dates, whether or not that's just like a clerical issue. That's something that we see. Sometimes we find missing documentation where maybe it was left in an office and didn't get mailed out to the vessel. Some of the required documentation is missing flag or class approval. That's some of the items we find there. Crew licensing and documentation. The U.S. Coast Guard is trained to look at crew licensing from all over the world. We see quite a bit of Russian, Ukrainian, Filipino, mariners from all over the world. And we're trained to look at those crew licenses to make sure that they have all the proper training, the certificates of proficiency, also their certificate of their licenses and things like that, just to make sure that they're meeting all of the requirements found in the IGC code and STCW. For those, we do find some deficiencies in crew licensing, although they're pretty rare. Missing flag state endorsements is probably our most common one. Sometimes we see that a license has expired and they have an application in, or they just forgot that documentation. But for the most part, we don't find too many errors with crew licensing. Another area that we examine on board a gas carrier will be the life-saving appliances. And this will include lifeboats, life rafts. But where the gas carriers differ in life-saving appliances is that the lifeboats, for example, are required to be fire protected if they carry flammable cargoes. And most gases will meet the requirements for flammable cargoes. So what is a fire protected lifeboat? Well, that's going to be one that has a water spray system and also an air supply. So in case of an emergency, the vessel can protect itself from any kind of heat radiation, and also protect the crew and provide them with safe air, breathable air while they're inside. Common deficiencies we find there regarding those systems. Sometimes we find that the water spray systems have been damaged. Well, something was dropped on them, which will pinch the piping. Sometimes we'll find that the equipment won't start, or in some extreme cases, we'll find that the hoses which provide the air oxygen for the crews will blow off of their cylinders. It's never a good day when something like that happens. And on the other side, rations, food rations. Sometimes we find that those are damaged and aren't adequate for the number of people that the boat can carry. Going to firefighting systems, gas carriers are unique in their firefighting systems and what they'll provide. Gas carriers do have a fire water main, but primarily for fighting fires on a gas carrier, we utilize dry chemical powder. And the reason for this is that dry chemical powder will break up the chemical chain and will stop the fire from continuing on. It won't stop the cargo from vaporizing, but it will put out a fire. The reason we don't use water on LNG or LPGs for that matter is the fact that these cargoes are cold. So when we put this ambient seawater, which is going to be relatively warm to that cargo condition, it starts to vaporize the cargo to such a degree that it's almost uncontrollable. So we want to control where the vapors are going. So typically, we'll utilize a water spray system, which will help warm up those vapors quickly and send them straight to the atmosphere versus finding a source of ignition. So we use the dry chemical powder to put out fires, and they also use the water spray system for heat protection, because LNG fires and LPG fires are quite warm, and also to help control where the vapors go. Okay. All right. The cargo containment systems. When a U.S. Coast Guard examiner is looking at a cargo containment system, these are foreign vessels for us, so we don't do too many. Well, to be honest, we don't do any cargo tank internals. We typically leave that to flag. The United States doesn't have any gas carriers to our flag, not yet anyway. But those internals are done by the flag state. So what we do is a surface inspection. We'll go on top of the cargo tank top. We can use an LNG carrier in this example. And we'll go look at a lot of the required items per the IGC code. They need to have fusible plugs in case there are fires on board, and these fusible plugs will then melt, releasing pressure inside, and then actuating deck water spray, and also emergency shutdowns on board the vessel. You can see in the picture on the bottom right with the red cargo tank top that the water spray there is being utilized, and that's a good example of what water spray looks like when it's activated on a cargo tank top. To keep going under there, we look at the instrumentation that we can find, whether that's the tank gauging, temperature sensors, pressure sensors, items like that. We'll also look at the relief valves, which were previously mentioned, the primary method of tank protection for both vacuum and pressure. Let's see. We also look at just general material condition. We look at electrical. In that picture on the bottom right, you can see two electric motors covered in black tarps. We check those to make sure that they don't provide a source of ignition for released vapors. Moving on from the cargo, I guess, and that's for LNG carriers. And again, I mentioned that a lot of these are different per gas carrier that we go on. Talk about gas-related instrumentation and what they'll provide. I mean, when we're talking about LNG carrier, they're going to have extra temperature sensors because the cargo is so cold. We'll find those on the hull in the secondary barrier. These tanks are if you think about like a box within a box, that's a good way to picture how these tanks are designed. For gas-related instrumentation, what we're inspecting there is we're going to look at the pressure sensors, the local sensors, to make sure that they're all working properly, that they have all the markings required on them, and generally that they're in good condition. The gas processing units, that's where we start to see a lot of variation on our gas carriers. For an LNG carrier or a gas processing unit is typically a little different, they'll utilize their boil-off gas as fuel. So what they're going to do is they're going to condition the vapors coming off of the cargo tank, which are just naturally boiling off as the cargo increases its temperature. And they're going to send those to the engine room to be utilized as a fuel. Or if their pressure is too great, they'll send it to a gas combustion unit where they'll boil off any excess to maintain pressures. On an LPG carrier and some LNG carriers, they have reliquefaction, where they'll take those boil-off gas vapors and they'll send them to a reliquefaction unit, where it'll condition all those vapors again and then turn them back to a liquid and return them to the tank. We typically don't find that too often in the LNG industry, although I do see them more and more as of late. And that's simply because it takes a lot of energy to turn a minus 162 degree cargo back into a liquid. So some of the gas processing units that we see on LPG carriers may include booster pumps and heaters and vaporizers. And what that does is that allows the vessel to take their cargo and send it to shore in a warmer, still a high pressure condition, but a warmer liquefied state. And if needed, they can vaporize their cargo, their liquid cargo, and send it to shore if the if the facilities aren't capable of housing or storing a liquefied cargo. And then gases, fuel systems, I touched on it a little bit, but there's quite a bit of technology in there, and we see that as we try to reduce our carbon footprint in the maritime industry to meet the International Maritime Organization's goal of 2050 of completely eliminating carbon, we start to see that a lot of the vessels, not just gas carriers, are being retrofitted with gaseous fuel systems. For LNG carriers, I mean, it's a standard anyway. They're going to have some sort of gaseous fuel system to where they manage that. But we start to see LPG carriers utilize propane or ethane or even LNG in some cases in their cargo tanks, in storage tanks to use as a fuel. So we can't say that LNG carriers are strictly the only platform that utilizes a gaseous fuel system any longer. Okay, we can go to the next slide, please. All right, we're talking about floating storage regasification units, or FSRU, and their operations. An FSRU deploys regasification capabilities to any port that can facilitate an LNG carrier. The vessel, which will comply with the appropriate IMO conventions, is equipped with high pressure pumps and vaporizers. And this equipment will draw the liquefied natural gas cargo from the tanks into its vaporizers and send the vaporized natural gas ashore. In the image on the right, you can see an FSRU. And in this case, it will look just like a standard, what I would consider a standard LNG carrier. You've got the cargo tank, which is the angled structure behind the bow over there. And then you've got this large square unit in the front. And what that does is that houses multiple vaporizers. Sometimes we see 6 vaporizers, 4 vaporizers, and that allows the vessel to rapidly convert its liquefied cargo to a gas and send that to shore to be utilized as an energy source. FSRUs are typically often used in ports that can't support a land-based regasification facility due to land availability or significant upfront capital costs. The portability, I mean, it's a vessel that's capable of converting this cargo quickly to a usable form. There's a lot of value in that. And they're used around the world. In the United States, we have the Northeast Gateway Deepwater Port, which is off the coast of Boston, Massachusetts. Israel has the Hadera Deepwater LNG Terminal, which does a lot of the same things. And then another example would be Bangladesh. Bangladesh uses an FSRU to help support their infrastructure over there. FSRUs serve many purposes. In Boston, for example, during peak energy usage in the winter months, they're used to provide the additional energy needed in that whole area without having to expand existing infrastructure. In the Northeast, it's an older area of our country, and a lot of the land has already been developed. So the infrastructure there sometimes doesn't have the space to put the additional equipment needed. So an FSRU is a great answer for that. We utilize that there. Bangladesh, similar regions or similar reasons there, and then Israel, they use it to help secure their energy sources. What's interesting is Bangladesh is a turnkey floating LNG terminal, right? I mean, a lot of these, that's what an FSRU does. It just allows the ability to convert and directly feed into the country's energy grid. They're very interesting vessels. But as far as an inspection standpoint, they don't differ too much from an LNG carrier. For all intents and purposes, everything is about the same except for the structure on the bow. And again, where that's just going to house multiple booster pumps and vaporizers. These booster pumps will just help support the cargo tank pumps and increasing the pressure delivered to shore. Typically, the shore storage facilities or shore pipelines are going to be maintained at a higher pressure. So in order to counteract that pressure, the vessel will provide a higher pressure to send it all to shore. And that's done via the booster pumps. The vaporizers, again, are going to be there to vaporize the liquid cargo found inside the cargo tanks and send that. Next slide, please. We talk about navigation safety. The Coast Guard does do this while the team is also inspecting the cargo side. So foreign vessels of 1,600 or more gross tons must meet the navigation regulations found within 33 CFR 164 when operating in the navigable waters of the U.S. If the AIS radar, radio nav receivers, gyro compass, echo depth sounding device, or primary gear or steering gear stops operating correctly, then the ship's master must notify the nearest captain of the port, district commander, or vessel traffic service. They all must be notified. And the reason for that, those are critical pieces of equipment, and we'd like to know that those things aren't operating so we can maybe implement some sort of safety measure like a tug assist or something. Okay. Next slide, please. We also try to protect our waters here in the United States, and we do that with 33 CFR 151. Vessels that are required to comply with Annex 1, that's oil. Annex 2, that's going to be noxious liquid substances, or Annex 5 of MARPOL, must comply with the requirements found at 33 CFR 151. These regulations cover the International Oil Pollution Prevention Certificate, the IOPP certificate, oil record book, noxious liquid substances, ballast water management, compliance, and many other subjects. Like I previously mentioned, we here at the Liquefied Gas Carrier Institute, we cover quite a few. We examine quite a few different gas carriers from LPG to LNG, and some of our LPG carriers must meet the requirements found in MARPOL Annex 2. So that's also part of our examination, where we'll look at some of the documentation for those, such as a shipboard marine pollution emergency plan, or SIMPEP, a IPP NLS certificate, International Pollution Prevention Certificate for the carriage of noxious liquid substances in bulk. We look at all of this, and it's quite a task to learn all the requirements found in the IGC code for these NLSs. The next slide, please. To summarize my presentation here, we covered where the United States Coast Guard obtains its vessel inspection authority. We covered the regulations that are applicable to foreign flag gas carriers, the procedures for having the United States Coast Guard complete a certificate of compliance examination, and the regulations pertaining to the navigation safety and also pollution prevention. Next slide, please. And I know that we're holding questions for the end here, so thank you all for listening. And let's go. Have a good day.
All right. Thank you very much, Mr. Brown, for that detailed presentation. Unfortunately, Commander Vaughn has experienced technical difficulties, so she wasn't able to present. All the same, the second presentation was very comprehensive. So thank you to our Coast Guard representatives for preparing that. All right. We will now be having our Q&A. We will be reading the questions posted in the chat box, and we'll also open the floor to participants who want to ask questions directly to our experts. Just please press the raise hand icon. So let's go first to the questions in our chat box. Some of the questions were already answered by our US representatives, so I'll read those I think wasn't answered yet. We have here a question from Mr. Don Jacob from the Department of Energy, Oil Industry Management Bureau, directed to any of the presenters. His question is, regarding the role of firefighting or putting out fire in FSRU, FSU, LNG FPSO, this is handled by Coast Guard, if docked at jetty near shore, if at sea, and Bureau of Fire Protection, if docked at jetty near shore. Is this the same in other countries? So this is directed to any of the presenters.
Yeah, I can field this first question here. And I'm sure Lieutenant Commander Hickey can take part of it too. But the Coast Guard in the United States doesn't fight LNG or LPG fires. That's just not our role. That shifts to the facility side, which starts to move out of my realm of expertise and into Lieutenant Commander Hickey's. So yeah, Lieutenant Commander Hickey, do you have anything for that?
Hey, good morning,
Hi,
everyone.
this
I'm
is
Lieutenant
Commander
Commander William
Vaughn. Can you
Hickey.
hear me?
Oh, yes, Commander, we can hear you.
Can you hear me? Okay, great. Thank you. Sorry, I've been having technical difficulties, and it's good to be able to speak now. So, as Mr. Brown noted, the role of the Coast Guard is all maritime. So, if there is a fire, LNG or LPG fire on the facility, it is the responsibility of the facility to handle that fire. Most of the time, they have third-party contracts with what we call third-party organizations that provide these services to them. We also utilize, obviously, our state and local partners are very important. We have a very good relationship with our state and local partners, and sometimes it's local firefighters who fight the fire. If it's a waterborne fire on a vessel, it might be, the state firefighters that do have their own vessels. So really the responsibility falls on numerous regulatory and government agencies when there is an incident. And if we can get my presentation, my last presentation on the last slide, I'll talk a little bit more about that a little bit later. Thank you.
Yeah, and as mentioned too, so FERC is the lead agency in reviewing and approving emergency response plans and cost sharing plans through Energy Policy Act of 2005. So the response, as Coast Guard has mentioned, will be partly dependent as to where the incident is, whether it's on the facility itself or within the navigable waters. Typically, for anything onshore, the state or local emergency responders will be responsible. That could be a third party, such as a private firefighting company through cost sharing, or it could be professional emergency responders that will partly have their costs offset by the facilities themselves through these cost sharing agreements. So that may include the additional fire apparatus or even firefighter tugs, depending on the risks of facilities. Part of that is determined through that WSA process, and then part of that is also through the emergency response plan reviews by FERC.
All right, thank you. So for our next question, we also have a question from Ms. Cynthia Moring of the Philippine Ports Authority. This is directed to any of the presenters. So the question is, what are the port facilities or infrastructures being put up or to be put up for LNG projects? Are these facilities or infrastructures will be located offshore or foreshore?
Hey, good morning,
Andrea,
everyone.
this is, go ahead.
Yeah, Commander, sorry. Yeah, I was just gonna answer that one. I'm Lieutenant Commander Hickey at the liquefied gas carrier in SUE. And so for LNG infrastructure, we're seeing export terminals, obviously onshore terminals here, but we're also seeing deep water ports, proposed deep water ports that are offshore as well. So we're seeing some of both. I hope that answers the question.
Thank you.
All right. So we also have here a question posted by Ms. Georgia Assistine from the GPDP, directed again to any of the presenters. Does the USCG implement separate regulations for typical LNG carriers as opposed to FSRUs or FSUs that are almost permanently berthed?
So the Coast Guard has deep water port regulations specific to FSRUs that might be operating outside of state waters. And our Office of Environmental Standards maintains those regulations. And we are a permitting agency for deep water ports. So we do have specific regulations for deep water ports that would include FSRUs.
And then similarly, for those that are in state waters where FERC might have jurisdiction, we'll coordinate with Coast Guard, and typically those vessels are classed. And you can have class for the vessel itself, including the topsides. So the topsides, typically for FERC facilities, will be required to be classed as an FSRU or FSU. And there's various class organizations that ensure compliance with those class requirements.
All right. So we also have a question from Mr. Eric Cruz of GPDP, directed to any of the presenters. Are there special requirements for docking or mooring of FSRU and FSU at the pier or jetty with respect to mooring speed, threshold of vessel motions, ship mooring locations that are different from those by existing pertinent codes and manuals? These info impact the engineering design of the docking structures.
Good morning again. This is William, and feel free, Joe, to chime in, and Commander Vaughn. So if I'm not aware of any specific additional requirements for FSRUs that's within our standards on some of the items that were referenced there. Certainly NFPA 59 alpha does require some of the speed monitoring when you're approaching the berth. But going back to our role as a cooperating agency with the FERC and the WSA process, that is something that we look at. And by I say we, the collective port community and stakeholders in the port that we're looking at and reviewing the safety and security aspects. And so if there's a proposal that an FSRU would be coming into the facility, we would look at the modeling and simulation studies. We would expect that those were looked at by the pilots as well as the company. And so if there was additional need of requirements within that terminal at that jetty, that should all be part of the WSA process and looked at. And then we would look at those risks and develop those mitigation measures as part of the overall arching permitting process for 127 facilities.
And for the vessel side, on the cargo tanks themselves, there are requirements found in the IGC code and in the CFR, which mention the angles of list that these cargo tanks must be protected by their pressure relief valves. So as far as threshold of vessel motions, that is taken into consideration in vessel design.
All right. There's a follow-up question by Sir Eric Cruz again, directed to any of the presenters. So the question is, the US is also tracked by typhoons or hurricanes like the Philippines. Are FSU, and LNG carriers allowed to dock, anchor, moor, berth in any US port or only in ports that are designed as all-weather?
So I provided a partial response to that. And we've seen both proposals at FERC for FSRUs, both of which have been either permanently moored and those that have been able to relocate. So part of that will be dictated by the natural hazards for the area and also the consequences of a mooring failure. So for example, you will have more notice typically for hurricanes and typhoons than you would for something like earthquakes and tsunamis. And depending on the location, you may be able to relocate those vessels in the events of hurricanes or typhoons, but you may not have the same notice and ability to do those in earthquakes and subsequent tsunamis. So depending on that in part, may dictate what can be done. That also will dictate in part what can be done from a mooring standpoint. It's very difficult to withstand the loads associated with tsunami waves. And it can also be difficult from storm surges as well. So there does have to be some consideration of what is technically feasible in that regard and the potential consequences if there is an event or failure of the moorings. Often the FSRUs are located farther offshore. So there tends to be sometimes less public impacts if there is a failure. However, there could be cases where the FSRUs are located more inland or more towards onshore, and that can be a little bit more difficult to mitigate some of those impacts. So we have seen kind of proposals for both, and it will, again, be just partly dependent on the situation of where that is FSRU is located, or FPSO, or other floating facility. And I'm not sure if Coast Guard has additional comment on deep ports or things they've experienced in regards to the marine vessels.
For the U.S. Coast Guard and Lieutenant Commander Hickey or Commander Vaughn can probably address this a little better than I can, but each captain of the port zone does have its own unique hazards, and they've got their own authorities for that. So I don't know, Lieutenant Commander Hickey, you want to talk about captain of the port authorities or Commander Vaughn and ports and waterway safety?
Sure, I can cover some of that. So because every port is unique and different, and every place in the United States is unique and different, what we have is the captain of the port authority, which allows the captain of the port to analyze the specific conditions of the operations of the waterway and of the port facility itself. So when it comes to safety, it's very unique to that facility, and it's up to the captain of the port operating with FERC and all the other agencies to make sure that the operation is as safe as it can be. But every single facility is very unique in its operations. They have different footprints, different risks, and different vulnerabilities. So it's up to the captain of the port to be able to analyze that and dictate, so to speak, what the safety measures and security measures are going to be for that specific facility.
All right. So let's move on to I think, the last question in our chat box. This is from Mr. Don Honor Jacob from Department of Energy, OIMB. To any of the presenters, is the tower yoke mooring system designed for FSRU commonly used around the world?
I could speak to a little bit here. I'm moving a little bit out of my expertise, but I do know the tower yoke mooring system is used in some places, not in all. I know that weather vaning is important for a gas carrier, or specific an FSRU. It's just one of the technologies that's available to these vessels.
So there's a follow-up question by Miss Cynthia Maring. Her question is regarding rules for stationary FSRU and stationary vessels, how it differs. I think this is directed to any of our presenters.
From the IGC code side, it would talk about the arrangements on the vessel, whether it's going to be a bow arrangement, a stern arrangement, or your standard port and starboard manifolds. If you've got a bow arrangement or a stern arrangement, there are additional regulations in the IGC code which the vessel must comply with. From the facility side, that's not my realm of expertise.
So do we have any
There are some different requirements for
Sorry.
So there are some different requirements for, quote, permanently moored vessels in the regulations. There are also going to be different requirements for stationary FSU, again, dependent whether it's where it's located in terms of state waters or federal waters and what jurisdiction it falls under. But some of the things to consider for stationary FSRUs or FSUs or FPSOs located near shore is there'll be some additional hazards that may need to be considered. So for example, and the consequences can tend to be greater if they're near shore because you're closer to populated areas if you're near shore with populations. So there are some differences in the design loads that are considered for fixed facilities. And so often some of the FSRUs and FPSOs, some of those codes may have return periods that are a little bit different. And that partly reflects typically their more offshore location. So sometimes if they're proposed at FERC and they are near populated areas, we would recommend that there are higher return periods to be considered because of their potential impacts to the public. So that's something for consideration. Another thing for consideration is typically when you have more topside equipment like you would for FSRUs, you typically have a little more congestion and less ability for spill control than you would for onshore facilities. So those types of things need to be considered in the overall risk in the analyses as far as what impacts could be for the public. You may be able to mitigate some of those or have larger spill containment systems for onshore as opposed to offshore. But again, that can be mitigated by larger separation distances from locating them more offshore. So there's just a lot of things to consider as far as what, in terms of consequences and likelihood of events. There's a lot of things, from security and all those other things that we discussed before that need to be part of the overall consideration of these facilities.
All right. So are there any more questions? So if there's none, thank you to all our experts for addressing the questions of our participants. Commander Vaughn, Lieutenant Commander Hickey, and Mr. Brown, and Mr. Kohout, who answered the questions via the chat box. And thank you all for your questions. We will now have a 10-minute break. Please be back here by 10:05 a.m. Thank you. All right. So are we all ready? Okay. Welcome back. Before we proceed to the second half of our training, we will have a short game to see how much you remembered from the earlier presentations. We will have two questions, one from each presentation. So those who wish to answer must type in me, as in ME, in the chat box. So we know who the first person to volunteer to answer. Those who will answer the questions correctly will receive a Grab gift card. The winner can choose from Grab Ride, Grab Food, Grab Mart, or Grab Express. So the game is only open for the government agencies. So GPDP team, kindly refrain from joining. I know, but we will open the game to everyone when nobody is able to give the correct answer. All right. So let's go for the first question. This is a bit tricky, so we will be a bit lenient. The question is, who is responsible for authorizing LNG facilities in the US? Type in me before answering. All right. So for JF Dimaano, MRO4,
U.S.
can
Coast
you
Guard.
can you tell us the answer?
The U.S. Coast Guard.
The US Coast Guard.
That correct?
So we will consult the experts for if the answer is correct. To our experts, is US Coast Guard the correct answer? Do we accept that
So
answer?
it's tricky because it depends where it's located. So for LNG facilities in the US, it will depend on its location and type of facility. So those that are located onshore or near shore would be jurisdictional to FERC for the authorization. For those that are located in federal waters or beyond state waters, it'd be the authorizing entity would be Coast Guard and MARAD.
So can we accept the answer of JF Dimaano, MRO4?
They all look good to me.
All right. So I think we could accept that answer because the answer depends on which federal agencies, if any, have jurisdiction. So which depend on statutes or legislation enacted by legislative branch of Congress and execution of legislation by the executive branch of federal agencies and by judicial reviews and determinations by judicial branch of federal court system that
Excuse
in
me.
turn,
Excuse
yes.
me. Yes, actually, in the presentation a while ago, there are 4 actually agencies involved in the LNG. As I recall, no, there is that the Department of Transportation, the Maritime Administration, the Department of Energy, and last is well, actually that's 4. I don't know if my recollection is correct.
Yeah, we accept your answer. So, congratulations. Please choose your prize. Do you choose
Sorry.
from this four? Grab ride?
Actually,
Grab
I'm
food?
from Batangas. I wonder if there is a Grab here in Batangas.
Oops.
That's a problem. I think there is no Grab here in Batangas.
All right. So we
Hmm.
will we will
Uh,
find a suitable gift
can
certificate.
I extend the gift to my office mate in Manila?
Ooh, sure, sir.
Huh?
Yes, sir.
Okay. If the Maritime Safety Office of Manila is present, uh, I would like to give that
Nice.
that prize to them because they are mas sila just a Grab.
Mm-mm. Ang
Mm.
bait ni sir. So thank you,
Oo.
sir.
Kasi
Just
walang Grab
send.
dito sa amin eh.
Sige po.
Oo.
Just send your email addresses in the chat box. Direct message to GPDP Angelo Pagopo.
Okay, thank you.
All right. Thank you. So, for the second question, name at least 2 areas examined under the USCG Certificate of Compliance examination. Name at least 2 areas examined under the USCG Certificate of Compliance examination. So we have Mr. Arnel Arnulfo Actu from MSS. What's your answer, sir? Hello, I think you are mute. In mute. Sir Aktub? Oh no. Okay.
That's correct.
So, Mr. Aktub answered life-saving and firefighting equipment. Let's see if that answer is correct. All right, you are correct, Sir Aktub. So the areas examined, but not all inclusive, are vessel certificates, crew licensing and documentation, life-saving appliances, firefighting systems, cargo containment systems, gas-related instrumentation, gas processing units, and gas as fuel systems. So congratulations. Please choose your prize. Grab ride, grab food, grab mart, or grab express. All right. He chose grab food. Thank you, sir. All right. Hope you like that little icebreaker we prepared for you. We will have another game after the next 2 presentations, so make sure to listen carefully to our resource speakers. So now we are ready to proceed to our next presentations, which is a continuation of the offshore LNG regulation, marine space and operational risks, now focused on marine transportation recovery unit and LNG as fuel. This will be the third presentation for us by Commander Vaughn. So Commander Vaughn, are you okay? I mean,
Yes. Good morning, everyone. Can you hear me?
yes, ma'am. Yes,
Okay,
Commander.
great. Thank
All
you.
right. And
Okay,
Commander
so yes.
Commander Vaughn will be joined by Lieutenant Commander William Hickey. Lieutenant Commander William Hickey is the detachment chief for the Coast Guard's Liquefied Gas Carrier National Center of Expertise and leads a team of liquefied gas subject matter experts who provide technical support to both the industry and the Coast Guard for all foreign and US flagged vessels and barges that carry liquefied gases in bulk, liquefied gas terminals, low flashpoint fuels of LFF, and LFF bunkering. Of particular note, Lieutenant Commander Hickey led the Coast Guards, serving as the navigation subject matter expert to the FERC, state and local agencies throughout the permitting of over 7 liquefied gas export terminals. Lieutenant Commander Hickey earned a Bachelor in Engineering and Mechanical Engineering from the State University of New York Maritime and served in the Coast Guards for 6 months in its Marine Industry Training Program. Ladies and gentlemen, once again, Commander Vaughn and Lieutenant Commander Hickey.
Great, thank you, everyone. And my apologies for the technical difficulties earlier. We really appreciate the opportunity to be able to present to you, and of course, we'll be available for any questions or any further training opportunities in the future. This current presentation is about the marine transportation system recovery that we utilize in the United States. Obviously, the marine transportation system is really conglomeration of different areas, right, of the system itself. There's facilities, there's the waterways, there's vessels. It's an entire system that, if anything goes wrong, it could impact other areas of the system, even on land. So what I have for you during this very short presentation, it's only 2 slides, is kind of just to explain how the United States deals with the transportation system recovery. Obviously, for liquid natural gas and vessels that carry any type of liquid or gases, there are different. I guess I should say there are different threats, so to speak, different things that could happen and that could impact the marine transportation system. So what you see in the picture here is one of the United States flagged vessels. It is a tote vessel that is both marine and LNG fueled. And you see the LNG gas tanks in green there at the stern of the vessel. So what we have in the United States is a marine transportation system recovery plan. And what this plan does is it supports the recovery and the restoration of the marine transportation system. Because of the complexities of the marine transportation system, there has to be a development of strategies, plans, and standard processes that can be rapidly implemented during any transportation-related incident unique to that port environment. Recovery and restoration focuses on port reconstitution. It identifies regional and national issues, and it also has the coordination of interagency and industry communications in order to have problem resolution. The Marine Transportation Unit Recovery Leader is a waterways management specialist, is a vessel specialist, is a facility specialist, and it's also a data entry specialist. And this is, you know, we talk about the recovery unit leader, but this is essentially a team of professionals with specialties in each of those areas. And that team will establish the recovery unit. They will obtain situational awareness once an incident happens. They will determine the impacts to the marine transportation system, and they will develop recommendations for courses of actions to recover that system. They also determine reporting requirements, whether it's up to other federal agencies or state partners within the Coast Guard organization, or even sometimes up to the President of the United States. And finally, once the incident is over and everything and the system has been recovered, they are responsible for demobilizing the Marine Transportation System Recovery Unit. So the Marine Transportation System Plan, it captures general priorities, and it is very mindful of critical infrastructure of each port. So part of the plan is to identify what each critical infrastructure is in order to protect that critical infrastructure if there is an incident in port. This includes fixed and on-water LNG operations, whether they be LNG transfer facilities, any LNG-powered vessel traffic, LNG bunkering barges for the port. The plan will also identify regional and local cargo priorities, whether there's cruise ships in port or container ships in port, or maybe there are petroleum tank ships in port. So all of those different systems are also captured in the plan. LNG may be a fuel or a cargo that stakeholders will consider a priority for the port based on what the port needs itself. But high risk or high priority marine transportation system elements should be captured. Every single one of them should be captured in the plan. Any response to an incident affecting the marine transportation system will be conducted under the incident management system or structures that are in place within the United States. The Marine Transportation System Recovery Unit is a unit under the planning section within the Incident Command System. And this unit is activated when an incident disrupts the marine transportation system. It is initially stood up and staffed by U.S. Coast Guard personnel. It can be augmented with government personnel and private industry personnel or port stakeholder representatives impacted by the MTS disruption. So, for example, if you have an incident with an LNG vessel, the Coast Guard will stand up the incident command system, and then the owner or operator or representative of that vessel will also join the Coast Guard in the incident command post and essentially they will stand up a unified command so that both responsibilities of the Coast Guard and the owners and operators are representative. Obviously, the goal of the Marine Transportation System Recovery Unit is to recommend courses of actions for the recovery and the resumption of trade. Currently, the marine transportation system in the United States supports about $5.6 trillion of trade incoming into the United States and outgoing as well. But it's about that figure that is so important to the United States, and obviously, if a part of the system is disrupted, then that could cascade or have a domino effect into other parts of the transportation system. Next slide, please. So our office in the Office of Port Facility and Compliance at Coast Guard headquarters, we are the program manager for the Marine Transportation System Recovery and Response for U.S. ports. What you see on the slide is Commandant Instruction 16000.28b. That is the planning and operations manual that we have put in place. It is an internal manual, but it requires an all-hazard plan for each captain of the port zone. Regional and national coordination with the DOT and Emergency Support Function 1, which is Marine Transportation. And really what that means is that we really worked closely together with our federal partners to make sure that maritime transportation is not disrupted in a manner that will affect our population, right? Sometimes we have seen hurricanes, for example, that will disrupt the maritime transportation system. And as it disrupts, as a natural disaster that disrupts the maritime transportation system, sometimes there are islands like Puerto Rico or Hawaii that cannot get their substantial needs. And so we make sure that we try to open up these ports as quickly as we can after a hurricane has passed. So we work very closely with our state and federal agencies to make sure that that happens. NAVIC 0418, that is the National Vessel and Inspection Circular 0418. These are guidelines for drafting the Maritime Transportation System Recovery Plan. And then the next NAVIC is the guidelines for the Area Maritime Security Committees and Area Maritime Security Plans required for U.S. ports. This second NAVIC requires salvage and response plans. It updates the exercise credit procedure and a cyber incident response plan template. So as the program manager, we make sure that every port in the United States is compliant with these NAVIC and navigation and vessel inspection circulars. And we make sure that subject matter experts administer the port recovery and salvage response program for the respective ports. So recently the Coast Guard developed the Marine Transportation System Recovery Unit Leader course, which provides uniform instruction and alleviates the burden of training on field units. So ports in the United States are obviously very diverse and have regional niches. To be able to account for these regional niches, Coast Guard sectors and districts facilitate localized training and information exchange opportunities that address local concerns and exercises. So this is, I guess, the point of this presentation that we really want to make prevalent is that the Coast Guard, address all hazards that happen within a port or within a system. And LNG obviously is one of those hazards once they're coming into port, whether it's a LNG facility or an LNG vessel, or if it's an LNG vessel or a vessel that uses LNG as fuel. These all present different hazards depending on each port that they're entering into. And so the Marine Transportation System Recovery Unit is a group of people that are at each captain of the port that will be experts within that port facility or within that port structure. And that includes also our state and local partners as well as industry partners. So pending any questions, that is the conclusion of my presentation. Thank you.
Commander Hickey, Lieutenant Commander Hickey, are you here to present?
Yes, ma'am. Can you hear me?
Yes.
I think that's Commander Vaughn's presentation. Do you have another one? Yep, that's it.
There. All right.
All right, great. All right. Good morning, everyone. I'm Lieutenant Commander William Hickey, and I'm currently serving as the Detachment Chief at the Coast Guard's Liquefied Gas Carrier National Center of Expertise in Port Arthur, Texas. It is certainly an honor and a privilege to present today to the Philippine Department of Energy and our counterparts at Marina in collaboration with the U.S. Department of Commerce and partner U.S. federal agencies as part of the Gas Policy Development Project. Thank you for your time during this presentation. Today, I will look forward to providing an overview of how the U.S. Coast Guard has approached the safe use of low flashpoint fuels throughout the U.S. Marine Transportation System. In doing this, I think it is important to cover every aspect and operation as it relates to low flashpoint fuels, marine industry here in the U.S., and how Coast Guard policy has filled the gaps in our current regulatory framework, providing industry with a pathway towards safety compliance. This is interesting in the question of who regulates or is ultimately responsible for the permitting of LNG facilities. For low flashpoint fuels and LNG bunkering facilities, and maybe a local port or a local state that ends up being the permitting agency here in the U.S. All right, next slide, please. So our agenda, I'm going to go over just give a brief introduction to our unit here at the liquefied gas carrier NCOE. I'm going to give an overview of the state of the low flashpoint fuel industry here in the US, currently operating and expanding. We're going to cover the LNG bunkering facilities in the United States that's currently operating and talk about the US policy that's utilized to fill gaps in our existing regulatory framework. We're going to talk about the US Jones Act bunkering, LNG bunkering barges that are operating in the US East Coast right now and how we've looked at that from a design perspective. We're also going to cover US flag Jones Act LNG as fuel vessels that are currently operating and the policies and international standards that are used to approve those design bases. We're also going to discuss foreign low flashpoint fuels that are currently arriving in the ports throughout the US. And then finally, talk about LNG bunkering operations, the actual operation in and of itself, to include the policies, field notices, and job aids that the US Coast Guard has created to help guide industry as well as the Coast Guard in evaluating the safe operations of LNG bunkering throughout the United States. Next slide, please. So our role, we're here at the liquefied gas carrier NCOE in Texas. We have 4 primary missions. First is augment units with qualified subject matter experts. So this is our operations piece to our mission, which is absolutely critical. So bottom line is we serve as a force multiplier for all Coast Guard units in conducting gas carrier exams or low flashpoint fuel inspections within their ports. So this year alone, just out of my unit, which is 7 personnel, we've conducted nearly 100 certificate of compliance exams throughout the US, augmenting Coast Guard captain of ports throughout the country. We've also deployed to marine casualties. We've oversaw emergency ship-to-ship lightering operations for LPG carriers. And so that's kind of one of our main missions, is that operational focus. So we serve, when we deploy, we serve under the authority of that local captain of port and OCMI at Coast Guard units. Our second primary mission is our workforce development. Mr. Joe Brown of my staff has talked about our liquefied gas carrier accelerated program, as well as a C school we sponsor. Joe is our training manager and runs both of those programs for us. Our accelerated program brings Coast Guard examiners throughout the country into a 3 or 4 week course, and we train them on how to conduct certificate of compliance exams on gas carriers that are entering US ports to ensure compliance with international and US regulatory standards. In doing this, we are also creating consistency, which is important for the industry, and that when we conduct a COC exam, we're consistent in how we're doing it, maybe in the Northeast, the US Northeast, as well as the ports in Houston and Port Arthur. We also, our third mission is to provide consultation and technical advice, both internal to the Coast Guard as well as industry. So we we don't typically create policy within the NCOE's function, but we advise Coast Guard headquarters units like Commander Vaughn's staff and her department if policy development is being created that relates to liquefied gas. We also are an avenue for industry to reach out to us if they have questions about, specifically for LNG bunkering, how they go about getting approval from the Coast Guard via the WSA process and a letter of recommendation. We can assist the industry with that and provide technical advice on that. In general, we do not have any Coast Guard authorities or command authorities, so it allows for a streamlined and more efficient communications with the industry. And we also reinvigorate industry partnerships, both locally within the United States as well as internationally. We are the Coast Guard's liaison to 2 major international organizations, SIGTO, and then likewise to SGMF, which is the Society of Gas as a Marine Fuel. Next slide, please. Okay, so the current state of the U.S. low flashpoint fuel industry. It's kind of funny. The bottom right-hand picture has always been used years ago when we were creating policy, but the operations haven't occurred yet. There wasn't approval, and that kind of gave you an idea of what it may look like. And I could say today, the ports are starting to look like that picture. So we currently have 4 LNG bunkering facilities operating in the United States. We have 2 in Jacksonville, Florida, 1 in Port Fourchon, Louisiana, and 1 in Seattle, Washington. We have 2 U.S. flagged LNG bunkering barges that are certificated by the U.S. Coast Guard, and they're currently operating in the U.S. East Coast. We have another one on under construction that should be operating within the next several months, also serving primarily in the U.S. East Coast. We also have currently operating 9 LNG fueled vessels that are flagged under the U.S. and 5 more that are currently under construction. That will get us up to around 14, 15 LNG fuel vessels certificated by the United States. And then finally, an outlook on the foreign low flashpoint fuel vessels. There's currently 206 LNG fuel vessels in operation worldwide, and another 327 LNG fuel and bunkering vessels on order. So we're starting to see here in the U.S. Foreign companies, foreign LNG as fuel vessels showing up to U.S. ports. We've also conducted our first LNG bunkering evolution to a LNG fueled crude oil tanker, actually, in the port of Jacksonville. So we're starting to see some growth there with foreign flagged LNG fuel vessels coming to our ports. Next slide, please. So I'm going to start off with liquefied natural gas bunkering facilities in the United States. I start out with that is because it's the whole industry had the whole chicken and the egg dilemma, and vessel owners and operators wanted to know that if they were going to invest in converting their vessels, that they had a place to receive the LNG. And so LNG bunkering facilities ended up being the first to bunker the U.S. Jones Act LNG fuel vessels that were built. And so I'll discuss a little bit about our policy and how it filled in the gaps to our existing regulatory framework. So 33 CFR 127 is applicable, and we briefly touched on it today, but it's applicable to any transfer of liquefied natural gas from shore to ship. So whether it's an export or import terminal, or if it's an LNG bunkering facility, our requirements in 33 CFR 127 are applicable. Now, the 127 regulations were mainly initially intended for large-scale import and export terminals that have a lot of cargo, that are transferring anywhere from 177,000 cubic meters of LNG to LNG carriers and upwards, as compared to an LNG bunkering facility that may transfer only about 2,000 cubic meters of LNG. So the scale was not appropriate for the LNG bunkering facilities, but it was still legally applicable to LNG bunkering facilities. The Coast Guard had established the Coast Guard OES Policy Letter 0215, and this provided guidance to the LNG fuel industry on how to comply with the requirements on 127 at the right size. So we're using, within that policy, it utilizes the captain of port and OCMI's authority to grant alternatives to the existing regulations that may be more appropriate for a smaller scale LNG bunkering facility. And as you may well know, there's different modes that are being proposed. An LNG bunkering facility may be a small scale liquefaction facility that's got a marine transfer area and LNG bunkering manifold at the jetty that can supply LNG as fuel vessels. Or it may be a tank truck that comes onto a facility and that's going to transfer LNG from the tank truck to the vessel. In either case, 33 CFR 127 applies, but this policy provides a more specific set of regulations or industry standards to utilize that the industry can utilize and Coast Guard can use to evaluate to make sure that the regulations are right size for LNG bunkering facilities and ultimately promoting the safe use of LNG fuel as a bunkering. This policy letter was also aligned with leading international standards with the IMO, ISO, and SIGTO as well. Next slide, please. So liquefied natural gas bunkering barges in the US. Again, we had existing US regulations in place, but they weren't specific to LNG bunkering barges. Our requirements in 46 CFR 154 are for self-propelled vessels, and they were unchanged since the 1970s. Also, 46 CFR subchapter D covers liquefied flammable gases, but those regulatory requirements were also unchanged since 1968. So the Coast Guard at that time evaluated the industry's concerns and developed a policy letter 0215 that was based on the Chemical Transportation Advisory Committee's recommendations and input, and has utilized existing regulations in 154 as a basis for compliance for these LNG bunkering barges in the U.S. And so that is one avenue that industry, that the U.S. LNG bunkering barge industry can use to gain compliance with the requirements in the Code of Federal Regulations. Coast Guard can also approve case-by-case designs via design basis letter and agreements. And on the right-hand side of those two pictures are two LNG bunker barges that are currently operating in U.S. East Coast. Next slide, please. Okay, U.S. flag low flashpoint fuel vessels. This one's slightly different in that the U.S. Coast Guard was actively involved in the IMO in standards development of the IGF code, and before that, the interim guidelines. The IGF code entered into force in January of 2017. It is required for any vessel that's applicable to SOLAS that wants to utilize low flashpoint fuels is required to comply with the IGF code. For U.S. flag vessels, CG Eng has issued a policy letter 0112 that provides equivalency determination. That provides an avenue for U.S. flag LNG vessels to gain design approval. The policy letter utilizes the IGF code as a basis and then provides more details on the administration's interpretation in every aspect of the IGF code where the administration is referenced. So it fills in the details to everywhere in the IGF code where it leaves it up to the flag administration. This provides one avenue a U.S. company can use to gain design approval by the U.S. Coast Guard, and it allows for a streamlined review process. Companies that want to go outside of the IGF code can still submit their proposal, and it will be evaluated on a case-by-case basis by the U.S. Coast Guard. So there's two avenues that a U.S. flag LNG fuel vessel operator can gain design approval. Next slide, please. So foreign flag low flashpoint fuels and how we look at that in the Coast Guard. We're starting to, like I mentioned before, we're starting to see foreign flagged LNG fuel vessels throughout our ports. And that's really, we're going to look at that as part of our overarching port state control program to ensure compliance of the IGF code aboard those vessels. Next slide, please. And then finally, LNG bunkering operations. So the two photos on the right are recent LNG bunkering operations, one offshore, one within the port in the U.S. To a cruise vessel. And we have several policies, field notices, and job aids that provide guidance to the industry, as well as the Coast Guard, on LNG bunkering from ship to ship or facility to ship that they can utilize to ensure the safe operation of LNG bunkering. CGOES Policy Letter 0115 provides the guidelines for LNG fuel transfer operations and training and personnel of vessels using natural gas as fuel. That policy is applicable both to U.S. flag vessels as well as foreign vessels that are operating in the U.S. navigable waterways. We also have a policy letter 0215 that provides guidance specific to the vessels and the facility that's conducting bunkering operations. Another key part within the U.S., and it's probably similar in the Philippines, is that a lot of these LNG fuel vessels, like container ships or cruise ships, also conduct other operations while they're bunkering. And so when they're bunkering traditional fuels, diesel fuel, what have you, they're still conducting other operations like container operations or passenger embarking or disembarking. And to wait, the industry was concerned that if those operations weren't allowed to continue, then there were significant delays in their route and significant delays on the industry. However, the Coast Guard looked at that as a potential risk. And so in addition to the risk assessments that we require as part of our 33 CFR 127 requirements, we also ask for a formal risk assessment to evaluate SIMOPS for vessels that are looking to conduct other operations during LNG bunkering. And so we have policy, CGOES policy 0117 that covers SIMOPS operations, as well as our unit's field notice that's guidance to the Coast Guard Captain of Port on how to evaluate and analyze those risks to SIMOPS. And then we also, our unit has a field notice and LNG bunkering job aid for ship-to-ship and facility-to-vessel operations. And that's a checklist that can be utilized for the industry and Coast Guard during a bunkering operation to ensure it's going to be safe. And so a lot of the U.S. regulatory requirements in 33 CFR, as well as international standards provided by SIGTO, as well as the IGF code or the IGC code, are within those job aids and can be used by the industry and the Coast Guard. Next slide, please. And that's it. I just wanted to wrap up with all of the policies that I referenced today are available on our website, and I could provide that to you. So we have everything. It's a one-stop shop for everything related to LNG or liquefied gas, to include LNG as fuel or low flash point fuels. All U.S. policies, as well as international policies, are all on our website. We also have a web TV series that we have, which is intended to have an informal training to our Coast Guard Marine inspectors. And so our TV series demonstrates how to conduct certain exams, like examine gas detection on a gas carrier or talk about LNG bunkering. We also bring in experts from class societies and other third-party organizations that come in and present as part of that TV series. And it's done via YouTube, so you can certainly access that if anybody's interested. Well, thank you so much for your time. I look forward to any questions you may have.
All right. Thank you very much, Commander Vaughn and Lieutenant Commander Hickey, for another thorough presentation. Commander Vaughn, we believe that we have missed your presentation on marine transportation system recovery a while ago. due to technical difficulties. It was supposed to be presented before the break. We're not sure if you already covered that in your earlier presentation. Um, would you like to go over those slides or? Commander Vaughn, are you here? I think hmm, Commander Vaughn.
Hi. Hello, can you hear me?
Yes, Commander Vaughn.
Okay, great. Excellent. Sorry about that. Yeah, so the presentation that I was not able to provide was the one that is titled LG Facility Safety. I did cover the Marine Transportation System Recovery Unit, but I can go over the LG Safety presentation now if there's time.
All right.
And I don't have visuals, so the first slide is titled U.S. Coast Guard Liquefied Gas Regulatory Overview, and it has a picture of an LNG vessel to the right.
All right. I think we have it. Let me share a screen.
Okay, great. Thank you.
All right. I think this is the presentation.
Okay, great. So this presentation covers the Coast Guard safety role over waterfront facilities and those that are handling liquefied natural gas. This was actually supposed to be the very first presentation that the Coast Guard gave, so I apologize if there's a mix-up with the presentations. We just were having some technical difficulties on our side. So if you can go please to the next slide, we'll go through the objectives of the presentation. So in this presentation, we will review Coast Guard missions. We'll also provide an overview of the Coast Guard role with liquefied gas. We'll go over the Coast Guard authority over waterfront facilities handling liquefied natural gas and key regulations for waterfront facilities handling LNG. And we'll also go over the waterway suitability assessment, which is the Coast Guard's role as a cooperating agency to the FERC's permitting role. Next slide, please. So the Coast Guard has in total 11 statutory missions, and they're all listed here. What you can see is that the Ports and Waterways and Coastal Security Mission, the Marine Safety Mission, and the Marine Environmental Protection Mission are all very prevalent in our responsibilities with liquefied natural gas vessels and facilities. Our Coast Guard is divided, the Marine Safety Mission is divided into a prevention mission and a response mission. So under prevention, we have the responsibility to inspect facilities, any waterfront facilities of the United States. We have the responsibility of inspecting U.S. flag vessels as well as foreign flag vessels. And we also have the responsibility to oversee the safety of the waterway. And that all falls under the prevention mission within the U.S. Coast Guard. Next slide, please. So with liquefied gas, the prevention, like mentioned before, we oversee facilities, vessels, and the waterway. This is generally a slide of how we are organized. So we have U.S. Coast Guard headquarters, which has CG Engineering, and those are the folks that are experts with any type of chemicals. They are the ones that review the type of hazards that they present, and they help us with understanding those hazards and understanding what regulations need to be implemented in order to make sure that there are safety provisions in place for the safe operation of facilities and vessels on our waterways. Coast Guard Office of Environmental Standards, those are the folks that create our standards, right? They create our regulations, they create our policies. They overview and they assist with creating Coast Guard policies as far as vessels, facilities, and waterways. The Coast Guard Office of Commercial Vessel Compliance, Coast Guard CVC, they specifically oversee any construction of U.S. flag vessels and all the standards that those vessels are supposed to comply with. They also oversee foreign vessels to include those carrying LNG. CG FAC is the Office of Port and Facility Compliance. That's the office that I am in, and we oversee all waterfront facilities with regards to any hazmat operations, hazardous material operations, liquefied natural gas, bulk operations. So we create policy for every single type of waterfront facility in the United States. CG5PTI, those are our traveling inspectors. So what we have is a group of subject matter experts with vessel inspections, and they travel to conduct vessel inspections for those vessels that are unique in their operations. So for example, we have traveling inspectors that do cruise ships. We have traveling inspectors that do hydrogen fueled vessels or liquid natural gas vessels. So that they are the folks that are our subject matter experts, and they travel to different places, not just within the United States, but also over the world to assist us in making sure that these vessels are constructed in a safe manner and also within the standards. And finally, the Marine Safety Center is our a group of experts that review vessel construction plans. So when U.S. flag vessels are being constructed, such as the ones that are fueled by liquid natural gas, those are the folks that do the plan review in order to make sure that those vessels are constructed in accordance with the regulations and with different standards, whether it be nationwide or worldwide. Up to the right side, you see the National Centers of Expertise, and Mr. Bill Hickey just presented. He is from our Gas Center of Expertise. We also have 4 other centers of expertise to include cruise ships, and those are also our experts in the field that train our personnel and make sure that that folks understand the standards that are in place for the different types of vessels and facilities. Just below headquarters to the left, you see areas, districts, and then sectors. The areas fall just under headquarters commands. The districts we have 17 districts in the Coast Guard, and those are districts that oversee the operations of several sectors, and then we have sectors which are the operational field units. So to give you an example of what that is like, for example, District 11 is on the west coast of the United States. They oversee all operations within the state of California, but in California we have many different sectors to include Sector San Francisco, Sector Los Angeles, and Sector San Diego. So District 11 would fall under our Pacific area, and they oversee the 3 sectors under their purview. Next slide, please. So this slide covers our jurisdiction over waterfront facilities handling LNG. What you see in the picture to the right is a LNG facility, and it is, you can see the red outline. That red outline is basically outlining what the safety regulations are for that facility itself. And so that waterfront facility, the safety regulations fall under 33 CFR 127. And basically that is for, making sure that the tanks are constructed properly, the pipelines are tested as required by the regulations, and all those other types of safety requirements. Also, you see the yellow outline, and what that corresponds to is the security portion of the facility. And so what you see is the waterfront area of the facility. That is where the vessels would tie up to. And then you see a pipeline that is also covered under that footprint. And the reason for that is because the maritime security regulations require anything that is attached to the maritime operation of that facility to be protected under the Maritime Transportation Security Act. So you have the waterfront facility and the pipeline. That entire area would be considered a secure area. And so there are additional security requirements for that area in itself. So just to recapitulate, the red outline indicates the facility footprint for safety requirements, and the yellow outline corresponds to the security requirements that are in addition to the safety requirements. Next slide, please. So as mentioned in a few of the presentations earlier, the Coast Guard has responsibilities for waterfront facilities handling LNG, and subject to these facilities are subject to key regulations which are delineated under this slide. So if there is a company that would like to construct an LNG facility, the first step in the process is to submit a letter of intent to the captain of the port, along with a preliminary waterway suitability assessment and a follow-on waterway suitability assessment. And those requirements can be found in 33 CFR 127, as well as Navigation and Vessel Inspection Circular 01/2011. And these can both be provided to you for reference. We'll make sure that we get those to you. The general design and construction of the maritime transfer area is generally falls under the NFPA 59A, which is also mentioned earlier. The person in charge of the shoreside transfer operations, that person's qualifications and certifications, those requirements fall under also under 33 CFR 127. These facilities handling LNG are required to have an operations manual, and they're also required to have an emergency manual. Those are both examined by the U.S. Coast Guard. And they also have a declaration of inspection, which makes sure that when transfers are happening, we have both the facility and the vessel signing that declaration of inspection to make sure that the transfer is safe and ready to happen. And so that has to be signed by both parties in order for that transfer to begin. So these are the main regulations for safety and security that fall under the U.S. Coast Guard's responsibility for facilities handling LNG. Next slide, please. So earlier, Mr. Hickey talked about the letter of intent and the waterway suitability assessment. So the waterway, and you'll see a picture of the actual process flow chart, which comes from Navigation Vessel Inspection Circular 02-TEC-11, which again can be made available to you for review if you would like. But the letter of intent and the waterway suitability assessment are required from the owner or operator of that facility when they are intending to build a new facility or when they are planning to construct additional structures or expand that facility in order to modify the marine terminal operations of an existing facilities. This letter of intent or waterway suitability assessment, it applies to both LNG and LHG facilities. The letter of intent is submitted to the Coast Guard captain of the port no later than the date of pre-filing request with the permitting agency, which is FERC. And it has to also be submitted at least 1 year prior to the start of construction of on that facility, whether it's construction of a new facility or construction to expand or modify an existing facility. The preliminary waterway suitability assessment is submitted with the letter of intent, and it provides an overview of the port, of the route that the vessels will be taking, safety and security risk assessments, risk mitigation strategies, and resources needed. So all of this is provided by the company. The actual assessment itself is conducted by the company, and then it is submitted to the captain of the port and reviewed by the captain of the port. The captain of the port can, once they review, they can return if they are missing some areas of concern or areas that need to be, or risks that need to be mitigated, that can be returned to the company with questions. And so it's essentially it's a two-way communication between the company and the captain of the port in order to assess the risks that are associated with this operation of LNG, and then that company, the captain of the port, will continue to talk to the company until all the risks are mitigated. Once all the risks are mitigated, then a follow-on waterway suitability assessment is due when submitting the application to FERC, or at least 180 days before transferring LNG or LHG. Next slide, please. So this is a general review of the waterway suitability assessment and also validation. So the requirement is in 33 CFR 127 again, and we want to make sure that the appropriate port stakeholders have been consulted. So this means towing companies, cargo companies, whether they're container companies or bulk grain companies, anybody that's in the port that has any stake into the safe operation of the port should be consulted before by the owner or operator during the waterway suitability assessment before it is submitted to the captain of the port. We also have to take into consideration any critical infrastructure along the proposed route that the LNG vessels will be transiting through. So for example, if there's an LNG vessel transiting through the port of New York City, then one of our critical infrastructure would be the bridges, or maybe the Statue of Liberty, or maybe the United Nations. These are all critical infrastructures that would be considered within the waterway suitability assessment. We also take into account the population density, which is something that Mr. Hickey mentioned in his presentation. Obviously, the population density is very important because we want to make sure that if there is an incident with LNG, the population is protected. So we make sure that those density figures are accurate and they are well represented, and any mitigation is in place during that waterway suitability, within that waterway suitability assessment, to make sure the population is protected. We want to make sure that the impact of those risk management strategies are included, and they also include the other port stakeholders. And we also want to make sure that there are resources necessary within the port to implement those measures, and that they are available in the event of an incident so they can respond. Next slide, please. So these are key regulations for safety on waterfront facilities handling LNG. The storage tanks have to be double walled. They have to be insulated. They have to prevent any gas from escaping. There has to be containment around the tanks that is capable of containing the entire value of the tank. They have to also be designed to prevent any gas from escaping. And again, make sure that that there is containment to contain the entire volume of the tank. Next slide, please. So the Maritime Transportation Security Act was enacted in 2002. This includes, this is an overview. It includes facilities that receive passenger vessels with over 150 passengers. Any vessels subject to SOLAS, foreign cargo ships over 100 gross tons, cargo and miscellaneous vessels subject to 46 CFR subchapter I, and any barge fleeting facilities which are prevalent in areas like Houston, Galveston, or Gulf of Mexico. It does not include facilities that are used for military purposes, any oil or gas, natural gas production or exploration, and mobile or isolated facilities. Next slide, please. So for those facilities that handle LNG under the Maritime Transportation Security Act, there are key regulations, and one of them is to make sure that there's limited access to persons with proper photo ID or an escort to those areas that we consider, or that the facility owner considers a secure area. So what this does essentially is it protects those areas from people that are not supposed to be in those areas. So what we have is a transportation worker identification credential that is verified before persons can access areas that are secure areas. So if you recall the previous slide that had the yellow outline, which is a secure area of that facility, only access would only be permitted to those persons with a transportation worker identification credential, which signifies that they have the right to access that area. So only those certain persons that can access are available to do that. We also have security patrols of the marine transfer areas, and they're conducted every hour in order to monitor, any activity that is happening in that area. Those areas are also monitored by manned personnel. We can have security officers that are roving. We also have CCTV systems that can be monitored, and we just want to make sure that these systems and these options are in place for detecting whether it's unauthorized individuals, fires, or any LNG releases. Security personnel that are on board that facility shall have the knowledge regarding security violation procedures, which means that they must have the knowledge to be able to report any security incident to the Coast Guard. And another requirement of the Maritime Transportation Security Act is to make sure that there are means of communication between security personnel and other personnel operating on that facility. So this is a general overview. Obviously, the regulations are a little bit more complex with regards to security. In the picture there on the right, you see a Coast Guard vessel with other towing vessels escorting an LNG vessel into port. When it comes to security, it is an all. We rely on our partners to be able to provide security to that vessel and to that facility. So, for example, in Boston, you can see that there are different options for securing that vessel, especially because these vessels transit through high population areas. Next slide, please. And that is my presentation on facility safety and security. Pending any questions, I appreciate the opportunity to brief. Thank you.
All right. Thank you, Commander Vaughn, for all of your presentations. For our last presentation, we have Mr. Thatch Nguyen, and he will be joined by Ms. Lindsay Constantino, International Transportation Specialist from the Office of Hazardous Materials Safety, International Programs of the United States, Department of Transportation, Pipeline and Hazardous Materials Safety Administration. Since joining PHMSA, She has organized large-scale diplomatic projects and represented the U.S. at the United Nations Subcommittee of Experts on the Transport of Dangerous Goods. Ms. Constantino is also the program manager for the Lithium Battery Air Safety Advisory Committee. She holds a Master's of Arts in International Commerce and Policy from George Mason University and a Bachelor of Arts from Cal Poly San Luis Obispo in California. Please welcome Mr. Nguyen and Ms. Constantino.
Thank you, and good afternoon. In this last segment of the presentation, I will discuss the LNG technologies commonly used at an LNG import terminal and the applicable technical standards. And then my colleague, Lindsay, will speak about the LNG trucking safety regulations. And then I will circle back at the end to briefly discuss hydrogen gas pipeline safety regulation. Next slide, please. Okay, this slide shows the flow of LNG product and natural gas in a typical LNG import terminal. On this slide, the blue lines represent the LNG flow path and the yellow lines represent the natural gas flow path. LNG carriers transport LNG from overseas export terminals to import terminals such as the ones proposed in the Philippines. And they're equipped with pumps that can be used to transfer LNG from the carriers to the terminal side LNG storage tanks. I want to point out that a vapor return line is not shown on this schematic, but is required by NFPA 59A because when LNG is pumped from the LNG carriers to the onshore LNG storage tanks, the void space in the ship containers must be made up with the boil-off gas from the onshore storage tanks in order to avoid a vacuum condition in the ship containers. LNG is then stored in LNG storage tanks and then transferred to the vaporization system for converting back to its vapor form. The onshore LNG storage tanks are equipped with transfer pumps, and the transfer pumps could be located either inside or outside of the tanks. There could be 2 stages of pumps to achieve the desired pressure level consistent with the natural gas pipeline requirements, depending on the location and pressure of the pipeline. High pressure LNG is routed to the vaporization system, which are essentially heat exchangers that convert LNG from its liquid phase back to its vapor phase or gas phase and then routed to the pipeline. Besides the vaporized gas, the boil-off gas from the LNG storage tanks, shown as the yellow line coming out from the top of the tank, can also be sent to the pipeline using boil-off gas compressors. Again, there could be 2 stages of compressions depending on the location and the pressure of the pipeline in order to achieve the desired pressure to overcome the pressure in the natural gas pipeline. Next slide, please. There are 3 main facilities within an import terminal, and they are the marine transfer facilities where the ships or the LNG carriers dock and unload, the LNG storage tank system where LNG is stored, and the vaporization facilities where LNG is vaporized back to its vapor form. Besides the 3 main facilities, other critical components in an import terminal includes the vapor handling system that handles the boil-off gas and the flash gas, the process control and safety system, protection system, electrical system, communication system, and security system. Next slide, please. So for the transfer system, it is one of the major facility in an import terminal. the transfer system is used to transfer LNG and other hazardous products into and out of the terminal plant boundary. In an import terminal, there could be more than one transfer areas, and they could be used for unloading LNG from an LNG carrier, loading the LNG trucks, bunkering, transferring ISO containers into the rail cars or metering stations for the vaporized natural gas. At the marine transfer area, unloading arms are used to connect plant transfer piping to the LNG carriers. At the trucking area, flexible hoses are used to connect plant piping to the LNG trucks. Regarding the code requirements, the federal safety regulations for LNG facilities, 49 CFR Part 183, incorporates by reference currently the 2001 edition of NFPA 59A for the design of the transfer system. But throughout my presentation, I will also reference the applicable chapters in the latest NFPA 59A edition, which is the 2019 edition for your reference. Chapter 8 in the 2001 edition of NFPA 59A or Chapter 15 in the 2019 edition applies to the transfer of flammable liquid and flammable gas. In general, NFPA 59A requires isolation valves and bleed connections at the manifold. So the unloading arms or the transfer hoses can be safely drained after an unloading or loading operation. 59A also requires a redundant set of isolation valves near the transfer area. And specifically for the truck transfer area, NFPA requires an emergency shutdown system in addition to the block and bleed connections at the manifold. For the metering station, NFPA 59A requires protection of downstream pipeline from exceeding the pressure or temperature limits. We normally see a HIPS or high integrity pressure protection system just upstream of the metering station that would trigger an automatic shutdown valve or isolate the import terminal when the vaporizer's outlet piping exceeds the set pressure. Low temperature sensors that are part of the safety instrumented system or SIS can be used to trigger the isolation of the import terminal from the pipeline when detecting low pressure at the vaporizer's outlet piping. In addition to that, NFPA 59A also requires communications from the transfer areas to other locations in the plant. Next, please. From the unloading docks, LNG is typically transferred into the storage tanks. At import terminals, LNG is stored in a low pressure tank system, and low pressure tank storage tank system is defined in NFPA 59A, the 2019 edition, as the containers designed for internal gas pressure of 15 pounds per square inch gauge or less. The four types of low pressure LNG storage containers recognized by NFPA, the 2019 edition, are single containment, double containment, full containment, and membrane tanks. In the US though, single containment and full containment tanks are more commonly used. Part 183 incorporates by reference NFPA 59A, the 2001 edition for tank design, and 59A devotes an entire chapter for tank design, construction, and testing requirements. The storage tank section is in chapter 4 of the 2001 edition, or in chapter 8 of the 2019 edition. In the nutshell, 59A references API 620 Appendix Q for the metal tanks, and the concrete tanks must comply with ACI standards. There are also design requirements in 59A for natural hazard, pressure relief valve sizing, insulation, and foundation. Please be noted that high pressure vessels can be used to store LNG, but normally at more smaller LNG plants and not normally in an import terminal. Next, please. This slide shows a single containment tank design. The single containment tank design may have more than one concept variance, and you can find the different concept variants in API 625. This figure, though, shows a concept for single containment tanks that are commonly used in the US. This containment tank concept includes an inner tank of low temperature metal, normally 9% nickel steel, for storing LNG. On this page, the inner tank is shown as number 1 in the blue circle. On this configuration, the outer tank is identified as number 7 in green color. The outer tank is normally carbon steel, it's vapor tight, and is designed to contain the boil of gas and keep the moisture from entering the tank. Number 3 is the metal roof that connects and rests directly on the outer tank. The outer tank carbon steel wall is not designed to contain liquid. And insulation is filled in the annular space between the inner primary tank and the outer tank. The side insulation is normally perlite, and it is number 6 highlighted in yellow. Insulation is also installed on the aluminum suspended deck above the inner tank as number 5, and also installed below the inner tank as number 8. For a single containment tank design, the impoundment system is the dike that is independent and separated from the storage tank. So in the event of a leak or a liquid spill from the inner 9% nickel steel tank, the dike will prevent LNG from flowing away from the storage area and propagate the incidents. The tank sits on a concrete foundation shown as red number 4. The foundation could be directly sit on the ground or elevated above the ground, depending on the soil condition. Next slide, please. And here's a screenshot of the single containment tanks taken from Google Earth at the Elba Island LNG terminal in Georgia. There are 5 storage tanks for LNG at this terminal. The single containment tanks require an independent secondary containment, and you can see the concrete dike surrounding each tank, serving as the secondary containment. The safety regulations in Part 183, Section 2181 require that the impoundment system must be sized for 110% of the tank maximum liquid volume. Part 183 also requires the tank dike must be designed for the impact forces, potential penetrations by windborne missiles, and the dike structures must be designed for the liquid head of the released LNG, erosion from the spill, effect of sun contact with cryogenic temperature, and the exposure to fire. Next slide, please. Double containment tank. This design is very similar to a single containment tank design. Basically, it consists of a 9% nickel steel inner tank and a carbon steel outer tank. The inner tank is designed to contain the liquid natural gas, while the outer tank is vapor tight and is designed to contain the boil off gas. A major difference between the single containment tank and the double containment tank is that the dike is now much closer to the metal tank itself, since the regulations in Part 183 require that the impoundment system must be sized for 110% of the tank maximum liquid volume. The dike must be now much taller in order to provide the required containment volume. Next, please. This is a screenshot photo from Google Earth of a double containment tank design used at the Ecoelectrica import terminal in Puerto Rico. You can see the concrete dike is very close to the outer carbon steel tank, and you can see the metal roof there. Next, please. This figure shows a full containment tank concept that is normally used in the US. The full containment tank design reduces the risk for a tank fire and results in a smaller thermal radiation exclusion zones. This concept has a concrete wall and a concrete roof. For the full containment tank design, the impoundment system is part of the tank. The dyed wall, number 2 in red, attaches directly to the carbon steel vapor wall. The thermal corner protection, shown as number 10 in dark blue, is designed to provide liquid tight protection at the corner where the concrete wall sits on the foundation. The thermal corner protection system is normally made of stainless steel and is welded to number 9, which is the bottom secondary liquid container, to provide all-around protection for the corner and the bottom of the tank from a liquid spill from the inner tank. And the next slide, this slide shows a screenshot of a full containment tank design used at the Cameron LNG import and export terminal in Louisiana. There are 3 tanks. So from the outside, you can only see the concrete wall and the concrete roof. Vaporization system, FIP9A identifies 3 classifications of vaporizers: the heated vaporizers, ambient vaporizers, and processed vaporizers. For the heated vaporizers, the heat sources are from combustion of fuel, electric power, or waste heat. The second classification is ambient vaporizers that use natural heat sources, such as the atmosphere or seawater on the FSRU. And the last classification is processed vaporizers that derive the heat source from another thermodynamic or chemical process. Heated vaporizers such as submerged combustion vaporizers or shell and tube vaporizers are commonly used in an import terminal. Again, Part 193 incorporates by reference the 2001 edition of FIP9A for the design of the vaporizers. And FIP9A then reference ASME boiler and pressure vessel code section 8 for the design, fabrication, and inspection of vaporizers. In addition to this reference, FIP9A also provides requirements for safe isolation and pressure relief valve sizing. Next slide, please. Besides the 3 main facilities that we just discussed, I will spend the remaining time quickly discussing the other critical facilities and system within an import terminal. So LNG is stored at its boiling temperature, and methane vapor would continuously boil off from the LNG stored in the tank. This is called the boil-off gas, or BOG. Methane gas may also flash off from the storage tank during LNG unloading or from recirculation. Another source of flash gas could be from process equipment during LNG transfer. So FIP9A requires that the boil off and the flash gases separated from the equipment and discharge through the relief valves must be discharged safely into the atmosphere or into a closed system. In order to comply with this requirement, a vapor handling system is designed to compress and put the BOG into the pipeline or route it to a flare or vent stack. Modern LNG terminals typically have a closed relief system where all the relief valves discharge to a common header and then routed to a flare or a vent stack. A closed relief system eliminates local PSV discharge and reduce the risk of ignition or harm to the plant personnel. The other critical system is the process control and safety shutdown system. Part 183's definition for a control system includes control valves and sensing, warning, relief, shutdown, and other control devices. PHMSA inspection program reviews the test records to make sure that the control system is tested annually. In an import terminal, the DCS or distributed control system controls the process. The SIS or safety instrumented system will shut down equipment or close isolation valves when the system exceeds a design set point. An example of the SIS is the HIPS or high integrity pressure protection system that was discussed previously. The HIPS protects downstream pipeline by shutting down the isolation valves when the pressure at the vaporizer outlet piping exceeds the normal operating pressure. Next, please. And the fire protection system is designed to minimize the consequences from a release of LNG or other flammable products. Part 193 incorporates by reference 59A, the 2001 edition, for the requirements related to fire protection system. And Chapter 9 in 59A requires an evaluation based on sound engineering principles, analysis of the local conditions and the hazards within the facilities to determine the hazard detection system, the fire water system, the hazard control system, emergency shutdown system, protective equipment, and the availability of plant personnel during an emergency, and training for plant personnel. In the latest 2019 edition of 59A, you can find the fire protection requirements in Chapter 16. And the photos at the bottom of the screen are they show two different types of flammable gas detection devices. The picture on the left shows a point gas detector that uses infrared technology to detect hydrocarbon gas and provides reading as a percentage of the low flammability limits. The photo on the right shows a pair of open path or line of sight infrared detectors that can provide continuous monitoring of hydrocarbon gas over a range of distance. For electrical system, Part 183 requires at least two sources of power for the electrical control system, communication system, emergency lining, and firefighting system. The auxiliary power source must be tested monthly for its operational capability and annually for capacity. Additional requirements for electrical requirements can be found in Chapter 7 of the 2001 edition of 59A, or Chapter 11 in the 2019 edition. 59A references NFPA 70 for the installation of electrical equipment, and also provides provision for electrical area classification, electrical seals, and electrical grounding and bonding. For communication system, Part 193 requires a primary communication system, a security communication system, and an independent and separate emergency communication system. For security system, Part 183 requires that LNG operators must prepare and follow a written security procedure. Part 183 also requires a protective enclosure surrounding the equipment in the terminal and monitoring of the protective enclosure, as well as other areas inside the terminal. And I would like to close out my presentation on the LNG technology and safety standards with a discussion on reference standards. NFPA 59A is a consensus standard for the safe design, location, operation, construction, operation, and maintenance of LNG facilities. And NFPA references roughly 50 other technical standards, including API 620 and ACI 318 for tanks, SME PPVC for vaporizers, boilers, and pressure vessels, ASME B313 for process piping. So when the regulation, when Part 193 incorporates by reference 59A, the 2001 edition, these referenced technical standards become part of the federal regulations. Technical standards can be updated at an interval of 3 to 5 years or so. That means we always have to think about keeping the regulation updated with the latest standard. So the challenge is how to review all the changes to ensure that there's no reduction in safety in each of the reference standard. What we can do is trying to participate on standard committee. In addition to that, PHMSA has an internal team who reviews the changes of some of the major technical standards, but we cannot review all of the tertiary standards. So it's always going to be a challenge.
All right, thank you. Hi, everybody. I think these are my slides. I'm ready to present on them. Hi, good morning or good evening, wherever you are coming from. It's a pleasure to be here with you this evening. My name is Lindsay Constantino, and I'm an international transportation specialist in PHMSA's Office of Hazardous Material Safety. PHMSA is comprised of the Office of Pipeline Safety, which you just heard from, and the Office of Hazardous Material Safety. The Office of Hazardous Material Safety oversees the safe transportation of hazardous materials, or as the international community calls them, dangerous goods, and energy products by all modes of transportation. That means I get to work on dangerous goods transportation by maritime, air, road, and rail. I will keep my presentation brief because we have the unenviable position of being one of the last presentations, and I think we're running a little bit late. So this is what I plan to talk about during my presentation, and really the bulk of it will be spent on training, security, and tank specifications. So if you could go to the next slide, please. Thank you. I wanted to provide a basis of the U.S. hazardous materials regulations. And this provides a very high level overview. So, the mad scientist on the left here, gets his material and he needs to classify his material, find out what it is. So in this case, the mad scientist has LNG. Okay, you go into our hazardous material regulations, you identify that it's a LNG, and then you need to contain that commodity correctly. And so you do that by, again, referencing our US hazardous material regulations and finding the appropriate packaging for that good. In this case, the mad scientist found the picture you see here in the middle, which is one of our standards, our appropriate packagings, which I'll talk about later. And on top of that is actually our office mascot. His name is Hazardous Matt with 2 T's, like the name. So I guess Hazardous Matt is driving this truck today. And so the driver wants to be safe because, if Hazardous Matt turns out to be a really bad driver and there's a rollover, when emergency personnel comes on scene, they can take a look at the placards that you see on the right-hand side of your screen and determine what type of commodity it is and then therefore plan their response accordingly. So we call this the 3 C's: classification, containment, communication. This is a very high level overview of how the US hazardous material regulations work. So with that out of the way, I'll go to the next slide. Great, thank you. This next slide is about training. In the US hazardous material regulations, we require these types of training if you are dealing with hazardous materials, or in this case, LNG. So the first one you see there is general awareness or familiarization training. This provides familiarity with general requirements of the US hazardous material regulations and enables the hazmat employee to recognize and identify hazmat. All hazmat employees must receive this training. The next one, function specific, provides a detailed understanding of US hazardous material requirements applicable to the functions performed by the hazmat employee. So in this case, it would be LNG function specific training. Each hazmat employee must be trained on this as well. Safety training covers the hazards presented by hazmat, safe handling, emergency response information, and methods and procedures for accident avoidance. All hazmat employees also must receive this training. The last two have to do with security, and I will talk about that next, but I also wanted to make you all aware that we require security training. Security awareness training provides a general understanding of the security risk associated with hazmat transportation and the methods designed to enhance transportation security. This training should include methods on how to recognize and respond to possible security threats. All hazmat employees also must receive this training. The last one, in-depth security training, provides a detailed understanding of a company's security plan, including company security objectives, specific security procedures, employee responsibilities, actions to take in the event of a security breach, and the organizational security structure. I also will want to add that initial training, or if you bring in a new employee, they are required to be trained in these areas within the first 90 days of their employment or a change in their job function. And training records have to be kept by the hazmat employer. And I will add, just from our experience, that training violations is actually the top violation that PHMSA sees. Training is crucial to ensuring a safe transportation system. And this is really something we're always working on at the department. One other thing I wanted to add on training is that our training requirements are very flexible and they are not particularly prescriptive. The US DOT does not review or certify or pre-approve any type of training programs. It's really up to the employer to determine what type of training works for them. And there's a whole different slew of companies that provide trainings that meet the employer's needs. Next slide, please. All right, so now moving on to security requirements. Before discussing this slide, I'll remind everyone that PHMSA's mission is safety. And in the world of hazardous materials, I like to define safety as protecting people from the risk associated with hazardous materials, or in this case, LNG transportation. Conversely, security in this scenario means protecting LNG, or your hazardous material, from people. After 9/11, security became a bigger aspect of our regulations, as you can imagine. We worked with the Transportation Security Administration, which is under the Department of Homeland Security, and evaluated security threats associated with specific types of quantities of hazmat considered to be high consequence if stolen or used for harmful reasons. And a large bulk quantity of a Division 2.1 material, which LNG is, qualifies for security plans. And you'll see what is required in the security plan, those 3 aspects on the screen there. So I won't get into details on all of that, but I will add that security plans must be in writing, and it must contain additional elements, including an assessment of transportation security risk for shipments of LNG, including site or location-specific risk associated with facilities where hazmat is prepared for transportation, stored, or unloaded, and measures to address the assessed risk. It also must include contact information for the staff who developed the plan and a plan for training hazmat employees. The security plan must be reviewed at least annually and revised if necessary. So the security plan must be available to responsible employees, and if it's revised, those employees must be notified. And lastly, the security plan must be made available to either DOT officials or Department of Homeland Security officials upon request. And at the bottom of the screen there, I put a link to our brochure, which would provide you helpful information in the development of security plans. All right, moving on to the next slide. Thank you. Here is our current authorized packagings for the transport of LNG by highway. So on the left there is the UN T75 insulated portable tank, and on the bottom right is the MC338 insulated cargo tank motor vehicle. On the next two slides, I'll provide you a very high-level understanding of the packaging specifications. However, one thing to note about both the specifications, I think a really good way to think about it is that it's really a tank within a tank. Actually, I think the US Coast Guard even sort of made that similar reference about one of their tankers, saying it's a box within the box. It's a very similar concept. Moving on to the next slide, please. All right, so here is the MC338 insulated cargo tank motor vehicle. On the top there, you'll see sort of a diagram of what it looks like. And on the bottom is a photo an inspector took a few years ago. So while you're taking note of the specifications on the screen there, I wanted to add that this tank car standard is pretty regularly used in the United States. Package integrity is crucial to transport safety. It's sort of your last line of defense, if you will. In preparation for this webinar, I looked up accident statistics by moving LNG by highway in the United States. There has only been 11 accidents that have been reported to us since 1996, none of which resulted in a fatality. And I think this really speaks volumes to the packaging integrity. So you'll see the statistics, or excuse me, the specifications on the left. I conveniently changed gallons into liters for you, but I did not on the 1, 2, 4th bullet did not change inches. So I apologize for that. I'm sure you all can do the math. Moving on to the next slide is the UN T75 insulated portable tank. And you'll see again, very similar to the MC338. Again, it's a tank within a tank, also made out of stainless steel. I'll add that the Federal Railroad Administration has done some fire testing on this specific tank, and the report is available online. So if you just typed into Google Federal Railroad Administration fire testing UN T75, the report should come right up. And that could be a really helpful resource for everybody. I will also sort of end this presentation by saying that in the United States, we recently approved a rail packaging for LNG transport by rail. But it seemed a little bit out of scope for this presentation. But if you'd like to learn more about that, or you want to talk about these packagings in greater detail, what I can do is put my email into the chat, and I'm happy to discuss that. With that, thank you for your attention. I told you I would be brief. I'm glad I could stick to that. And then I will pass it back to my colleague who I think wants to present on the last 3 slides. The next slide. Yep. Thank you.
Okay. Hi again. So I'm going to speak briefly on hydrogen gas. Um, we're gonna have another PHMSA engineer to speak about the hydrogen gas. We specialize in hydrogen gas, but he can make today session due to the short notice. So I'm gonna try my best not to screw things up. So PHMSA and state pipeline safety programs regulate more than 2.8 million miles of gas and liquid pipelines, with the majority being gas pipeline. Hydrogen gas pipelines and hydrogen blending have reemerged as hot issues. Today, both hydrogen gas in the US, most of the hydrogen gas is produced by burning fossil fuels. And it appears that over time, hydrogen production from electrolysis using renewable energy and water, referred to as green hydrogen, is going to increase greatly. The challenge is that the appliances and other end users need to be adjusted to burn hydrogen or hydrogen blended gas efficiently and safely. Low hydrogen blends is most likely to be the most compatible with existing pipeline infrastructure, but there are many variables to be considered, and the subject is of great interest and study in the US and abroad. PHMSA and state partners regulate over 1,500 miles of hydrogen gas transmission pipe operated by 42 operators. Since 2010, hydrogen mileage has only shown a modest increase to date. These transmission pipelines are of a shorter, more local nature and concentrated in the Texas and Louisiana Gulf region. PHMSA has had regulations on the transportation of hydrogen by pipeline since 1970, and the regulations guiding the transportation of hydrogen are in the 49 CFR Part 182. There are limited regulatory differences between hydrogen and natural gas pipeline transportation. A notable regulatory difference is when hydrogen gas is intended to be used as feedstock for a manufacturing process, does it need to be authorized in class 4 or class 3, class 3 and class 4 locations. And section 192.53 is applicable in that it requires material used for pipe and components to be chemically compatible. Current PHMSA regulations do not specifically address natural gas hydrogen blends, although the requirements for piping and components to be chemically compatible in 192.53 is still applicable for all gas transported. Hydrogen gas and hydrogen blends in natural gas appear to be a promising fuel to reduce greenhouse gas emissions, and PHMSA will be ready to meet the challenges ahead in maintaining pipeline safety in the US. And that will conclude my presentation.
All right. Thank you very much, Mr. Nguyen and Ms. Constantino, for that very informative presentation. We will now be having our Q&A for the last two presentations. Again, you may pose your questions in the chat box or press the raise hand icon. So let's go first to the questions in our chat box. Our speakers are very proactive in addressing the questions in the chat box. I think all questions have already been answered. We appreciate your detailed responses. So do we have any more questions? Mr. Don Jacob has a question to any of our presenters. So before the quiz time, let's answer this question by Sir Don. Can you monitor and control all operation and maintenance of LNG terminal outside of the facility, say outside the country? This is to any of the presenters.
I guess the question is remote monitoring of the and control of the terminal. I'm not sure about outside of the country, but I think there's a requirement in Part 183 that if a plant can be unmanned if that plant can be monitored and controlled from a different location. But yeah, outside of the country, this is not something that I'm familiar with.
Sir,
To add to that,
what
FERC,
I mean also by outside the country, I just maximize the distance. Actually, if you can control the LNG terminal operation and maintenance outside of the facility.
so DOT regulations do provide for that option. FERC has not allowed for that option to take place for jurisdictional facilities to date. There are some concerns if there is unmanned operation as far as its response times. So in part, it will depend on that. If there is to be remote operations, there could also be cybersecurity concerns. ISA 84 and ISA 99 have some standards that are associated with cybersecurity that can help mitigate that issue.
Sir Don, you're raising your hand.
Yes, sir. Yes, sir. Yes, ma'am. Yes, I am also aware of the security of the facility. If there is such a technology of being able to control the facility outside of the perimeter of the facility, but my other question is, for example, you are the company, the technology that constructed the facility, and you have to monitor every equipment, every material, if they are functioning right, so you can inform the operator, or the operator can notify you to double check it without going to the facility, so that it will be more efficient to operate and maintain the facility with more efficient line of communication. So for example, the technology provider, the company that constructed the facility has specialists that they can send to the facility immediately while informing the operator, something like that, together with the materials or equipment needed for the repair or maintenance. That's what is also what I am pointing out, sir.
Yeah, I think it's important to note that DOT PHMSA has regulations that cover a much broader range of facilities and sizes. So you might have facilities that are very small compared to import terminals, for example, and those that are traditionally under FERC jurisdiction, which tend to be the larger facilities. So there could be differences in allowances based on that. But so therefore, for larger facilities under FERC jurisdiction, we have not allowed for the unmanned status up to date. But in certain more remote locations with smaller facilities, it may be more common and more practical. And in some situations, partly because of the risks are quite different.
Okay, sir. Thank you.
All right. So We also have another question from Sir Eric Cruz of the GPDP regarding terminal pipelines to shore-based containment structures. Are they required to be on or under the pier or trestle deck, or can they be subsea, like fiber optic cables? Or will this be up to the owner or proponent?
PHMSA regulation
So for
does not.
jurisdictional, yeah, go ahead.
No, yeah, I was just gonna punt it over to you or the U.S. Coast Guard, because PHMSA regulation do not cover the trestle part, the design.
Yeah, so although there's no prohibition against subsea pipelines in the federal regulations, either PHMSA or Coast Guard or NFPA 59A, there are some unique concerns to be considered. And recently, NFPA 59A, probably 1 or 2 editions ago, incorporated specific standards to address subsea pipelines and pipe-in-pipe configurations. However, they still have some unique challenges with them. Part of that is the allowance for thermal contraction for these pipelines. LNG, given that huge temperature swing, often requires expansion loops. You can't do that as easily with subsea, so then you have to use specialized materials. There could be concerns also with anchor drops and drags that need to be considered. Some of this is covered in the newer 59A editions. However, FERC has been looking at them more on a case-by-case specific. I don't know if 59A addresses all of the concerns that we have brought up in our reviews, but it's not that it's prohibited in any way.
All right, so Sir Don, you're raising your hand.
Yes, sir. Yes, ma'am. This is also directed to any of those presenters. My other question is related to my first question regarding the remote control of the facility. If you are outside the facility, it also covers safety and security of the facility. Are there countries practicing said technology, or is the US also practicing said technology? That's my question, sir.
Again, there's not, so there is a FERC jurisdictional facility that has moved to unmanned operations during certain times, but has not sought the permission of FERC to do so. So aside from that one particular facility, there are no facilities under FERC jurisdiction that are unmanned or remotely controlled. However, there are a number that we recognize outside FERC jurisdiction within the US that are remotely controlled. Again, those tend to be the smaller facilities.
Yeah, PHMSA regulations allow remotely control, but to my knowledge, operators do not want to do that. They want just to monitor or view from an offsite location, but they don't want to allow control because anything can go wrong if you allow that control away from the plant control center.
Okay, sir. Copy, sir. So that means
So there are
there
no
is a technology
or export terminals unmanned.
Kalimutan ko
In the
mag-read.
US.
Go ahead, Sir Don.
Sir, as a continuation to my question, so there is a technology, but there is a FERC regulation that should be followed regarding said use of remote control technology. Is that correct, sir?
There has not There is no import or export facilities under remote control, and FERC has not allowed for any remote controlled facilities to date. But again, that's other non-FERC jurisdictional facilities have remote controls. So there is no provision yet for FERC facilities that have been approved that have remote control capabilities. And again, larger facilities tend to have 150 plus personnel on site. It's difficult to perhaps have remote control for these larger facilities that require such larger staffs. And there isn't a cost savings as there would be for smaller facilities that you can aggregate and have a operator responsible for more than one facility.
And I also want to share that, oh, go ahead.
Go ahead, Mr. Thatch.
Yes. So the regulation is very clear that if for and Andrew's absolutely right. Usually, import and export terminals, the large scale plants, they have hundreds of personnel, so it would never be unmanned. But there's a peak shaver within FEMSA jurisdiction that recently wanted to have the plant unmanned during certain hours during the evening and nighttime. But the problem is they do not have control capability offsite from the remote away from the plant. So that pretty much, that does not comply with the code.
Thank you, sir. Thank you.
All right. So, Ma'am Melit Villanueva of GPDP raises her hand.
This is actually probably missed this topic. I'm not sure if this was discussed regarding land-based LNG trucks in transporting LNG. I assume the Department of Transport is monitoring this or managing their compliance. Is there a set of policies you can share with us? Because at the moment, we don't have policy on that. And we are trying to drop one, and we would like to get, policy-based that is used in the US. Probably might be applicable to the Philippines.
I can answer that. So yes, you are right. It is under the U.S. Department of Transportation.
I can't hear you, Miss Constantino.
Can you hear me now? It says I'm off mute.
A bit choppy.
I've turned off my video in hopes that it's better quality.
That's better, yeah.
Okay, apologies. I hope everyone was able to hear me previously then. I apologize if that was not the case. So you are correct. It is the U.S. Department of Transportation, but I will say it's there's two agencies within the U.S. Department of Transportation that have oversight on LNG trucks. The first being my agency, the Pipeline and Hazardous Materials Safety Administration. We have the requirements on the packaging, the security aspect, the training of drivers, etc. But I will also add that the Federal Motor Carrier Safety Administration, FMCSA, which is also under the U.S. Department of Transportation. They have inspectors around the country who will inspect those LNG trucks because they have a much larger inspection staff than we do at FEMSA.
Perhaps I can email you, Ms. Constantino, to get further details on this.
Absolutely. I'm happy to discuss over email.
Okay, thank you very much.
All right. So, Sir Don, you're raising your hand again.
Yes, ma'am. This is related also to the questions of Mamilit to Miss Constantino regarding the land-based uh, virtual pipeline using trucks or lorries and railroad trains for transporting LNG. Uh, I just like to know for in the US regarding the containment system and the product itself, LNG, that is handled by a different agency, and then the lorry itself, the truck, that is also handled by another agency. Am I correct? So the Federal Safety Motor Administrator, that is that similar to the DOE in the Philippines or similar to the Land Transportation Office also in the Philippines?
I will be honest, and I would say I do not have enough familiarity with how the Philippines is set up to make us a statement on that question. But the Federal Motor Carrier Safety Administration, they will work with my agency, which is the Pipeline and Hazardous Materials Safety Administration, in truck inspection, so on roadside inspections. But the Pipeline and Hazardous Materials Safety Administration, we have the responsibility of writing the regulations.
And then Lindsay,
Copy,
also,
ma'am.
I guess
Thank
for
you.
rail, you have the FRA as well.
Oh, thank you for reminding me that as well. So very recently, within the last year, the United States approved a rail packaging for the transport of LNG by rail. And we work very closely with the Federal Railroad Administration, which is also under the US Department of Transportation. I will say our rulemaking that allowed for the transport of LNG by rail is currently in the US court system right now. So I actually can't say much more about that rulemaking because it is being reviewed by the courts right now. But that information is all online. And if you did want to email me, I can provide you with the final rulemaking, which provides a lot of information on LNG by rail transportation.
Thank you, ma'am.
You're very welcome.
All right. In the interest of time, we can accommodate only one more question. So, do we have any more question? Only one more question. All right. So to close today's training, may we now call on Assistant Director Rodela Romero of the Department of Energy Oil Industry Management Bureau to deliver her remarks.
Good afternoon, Angelo. Thank you very much. In fact, I just want to join also your quiz time. Unfortunately, was not able to hear all the presentation. So I just give my closing remarks.
Sayang.
Okay. To our active participants, experts, resource persons, supportive partners, efficient organizers, and to my very own energetic DOE family, good afternoon to all of you. All those adjectives I mentioned to all of you summarize the success of this half-day training. I am supposed to join you at the very start of this training for me to learn more on the regulatory aspect of LNG and other interesting topics. Unfortunately, due to an equally important meeting, I need to sacrifice and look forward for other learning opportunities. Now, allow me to express our appreciation to GPDP2, the U.S. Department of State, and the Commercial Law Development Program for helping us organize the training today. We likewise thank our esteemed resource speakers who didn't mind the time difference. I think after this, you can now take a nap and relax just to share their expertise with us today. We greatly appreciate the time and knowledge you imparted to us during this training. This training is very important for the DOE and to my other colleagues in the government. As regulators, we need to be equipped and capacitated for us to perform our tasks relative to LNG development and natural gas in general. In the Philippines, we can consider LNG projects as projects of national significance. It is also seen as government-private sector partnership. Therefore, my co-government agency must make a favorable environment for the entry of the private sector. We need to implement the ease of doing business that would fast track our licensing and permitting needed for the LNG project. I think the future of the LNG in our hands. Again, let me call an appeal for everyone to work hand in hand in order to develop an open, efficient, and transparent and rule-based LNG market that will prepare the economy of our beloved Philippines. Again, on behalf of the Department of Energy, particularly our Bureau, the Oil Industry Management Bureau, and in particular our Secretary Kusi, thank you very much for your active participation and for the support of everybody for the LNG development. Stay safe and mabuhay to all. Thank you very much. Back to you, Angelo.
Thank you very much, Assistant Director Romero, for that inspiring message. So before we conclude the training, may we please request our speakers and participants to open their cameras for a quick group photo. Let us flash our beautiful smiles. All right, everyone ready? In 3, 2, 1, smile. Smile. There are 4 pages here, so again, 3, 2, 1, smile. All right, thank you very much. We would like to inform you that we have posted the link to a short evaluation regarding today's training. We hope you can take time to answer it. So we would greatly appreciate your feedback. Before we officially end, we would like to remind everyone about our third training, which is scheduled next Thursday, July 29 at 9 a.m. Philippine time. So the third training will focus on the technical aspects of LNG. We hope to see all of you there. So that concludes our training. We once again thank our resource speakers for all your time and effort in putting the presentations together. Thank you also to all our other U.S. colleagues and representatives who joined us today despite the time difference. We likewise thank all the agencies and government units for your active participation, and we look forward to working with you and seeing you in GPDP's future activities. Have a nice afternoon and evening, everyone. Stay safe.
Thank you, ma'am.
Thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you, everyone.